This is right after the morning next to the reception. It's always good to see people who are surviving. Great. So we're starting with a little bit of late to just wait people, but now I think we're good to go. So we will start with this with the third thematic session on modeling and analysis, and it's going to be chaired by Kyre Gillette from Informatics Department, University of Oslo. So the stage is yours.
Okay, thank you, Chare, and welcome everyone this morning. The first speaker out is Tejaswini Kelkar, who's going to talk about embodied AI in Hindustani classical music. So please give it away, Tejaswini.
Thank you. Good morning, everyone. And welcome to this early morning session. I am going to talk about embodied AI in Hindustani classical music. The short answer to this very clickbaity title is there one? No. But I'm going to problematize this, I guess, concept and some ways in which I've tried to work through trying to understand how to approach the question of embodiment in a music that has representational challenges as well as historic ones. To lay the groundwork, I think I use the words NICM and HCM interchangeably. One of them means Hindustani classical music and the other one means North Indian classical music, and depending upon context, it's about differentiating between the two classical musics of India versus the whole South Asian region and so on. So both of those things mean the same thing, and both of them are based on scales and grammars, essentially, overlaid on top of each other. Most of the study, especially of late, has been revolving around three main areas in this, especially relating to embodiment in North Indian classical music. And the first one, according to me, is the performative element of motion in Hindustani classical music, which is about analyzing how musicians coordinate with each other and communicate the musical intent and the contour of improvised phrases. The second one is semiotic, which refers to the symbolic aspects of how this communication is somewhat iconic. And the third one is relating to pedagogical aspects, which is how does gesture and the embodied nature of singing this particular style of music learned, and how is the gestural element of pedagogy inherent to being able to transfer the grammars that are required for learning this style. Recently, there are even other approaches relating to interpersonal entrainment, synchronization, and movement coordination that people have studied. There is a recent paper by Jakubowski and others. As a style, this classical music is heavily vocal-oriented, which means that the soloist, vocalist, and of course, yes, there are instrumental soloists as well, but a lot of it is based on instrumental singing, and so refers back quite often to the vocal tradition, which is gesturally quite expressive. No HDMI voice, that's fine. It's fine. I don't have so much more music, sorry. I just, because it's a 6-minute talk. In representational approaches, what I was interested in, both in my master's and later on, is how to integrate the representation of the notation of the music, which looks like DNA strings, like just syllables written one after another, and how to integrate that with the phrasal quality of the enunciation of the singing. I've got some pictures here. One of them is from Martin Clayton's work about kind of a rough annotation of gesture, and in this regard, in the beginning of my study, I took a very kind of linguistic approach towards studying gesture, which does not mean computational linguistics as in generative theories, but more paralinguistic embodiment, which would mean that the co-production of gesture and music is essential to the happening of both of them, and one of them is not ornamental or exclusive to the other. But what I started noticing was that pitch graphs, as on the right, are kind of getting representational currency in the domain of analyzing not only North Indian classical music, but other types of music which are more shape-oriented and have less pitch class set data available. And in this domain, there is some recent work with artificial intelligence about melodic time series matching, raga recognition, raga similarity, so about kind of matching melodic groups and finding out how they add up together, and classification problems. Now, the thing that is fun to me in this is that a lot of these data sets think of raga as a very static entity, but even for the last 100 years, we have a lot of documentation of wildly changing profiles of interpretation of the same rag, not only improvisationally, but in its very nature. There are lots of conflicts, oftentimes about the kind of named items, category elements, having two different versions, for example, two different groups of pitches altogether, and so on. And I guess I want to say all of this because what do we care about kind of AI within a pre-existing musical domain? But I think that North Indian classical music is sort of a nice play field, or it's less about kind of domain-specific approaches towards doing the same things that we already can do from this music, but it applies to kind of lots of other types of music that suffer from the same problems. One of the ways in which I tried to approach this was through the sketching paradigm, in which we got a lot of people to sketch melodic phrases that they heard. And then on the right over there, it's an old paper in NIME about converting sketches into kind of valid raga grammars and how to go about choosing raga grammars and being able to convert from contours into a valid phrase, because kind of valid grammar is in the essence of being able to create rag. But later on, I transposed this work into motion tracings of phrases in the mocap lab over here and at musicology, where people represented these phrases through gestures. And then later used another classification approach to build a multimodal data set and use canonical correlation to represent melodic contour classification using melody and motion. So it is kind of closer in a way than where I was with sketching to generation. However, I think especially in 2022, it's important to remember that AI approaches could actually be quite a lot of things, and not just deep neural networks. We played around a little bit with L systems and Markov chains and old kind of automata and those kinds of models, which, what kind of AI is that? We don't know. But I was also working with an RNN paradigm to generate kind of text-based phrases, and this ended up actually in, is it called published when you play a musical piece that, anyway, whatever. We play this piece with a band and several. And then finally I was working around with some notional ideas of raga graphs and melodic entities. So I guess the point of this whole presentation is that representational approaches guide heavily our understanding of what can be done with artificial intelligence style approaches. But for me, I think integration of the element of movement is essential if we have to work with not just North Indian classical music, but more. I think I'm out of time and breath. Thank you.
Thank you, Tejaswini. So.
Okay, cool. I don't have anything with it.
And we'll do questions to the speakers in the last part, in the panel part of the session. But please note down some questions for Tejaswini.
It's also like it's just for the other presenters too. So we should not go with the highest resolution we have because there's a problem with there's the video mixer up there which sends the this to live stream. So this is why whoever is presenting, make sure to choose something closer to 1080 or 1280, something like that.
Okay. Yeah. So the next speaker will be Oluremi Falowo, who is going to talk about embodied music emotion representation learning with deep multimodal networks.
Yep.
So are you ready, Oluremi?
Yeah.
Yes, please go ahead.
Hey guys, I'm Oluremi, and I'm from Queen Mary. And today I'm going to talk about my attempts at learning an embodied music emotion representation using deep multimodal networks. First of all I want to kind of place it within the research area. So here on the left we have Mazzola's what he calls the cube or three-dimensional cube of music ontology. In one dimension you have realities, another you have communication, another you have semiotics, and it's quite easy to see how each of these dimensions relate to tasks that have been done in music information retrieval and deep learning for music in general, i.e. things like realities relate to neural audio synthesis, whereas communication and semiotics relate to things like generative tasks for composition. But he argues that this misses another dimension which we're all interested in, the dimension of embodiment. But it's quite hard to understand how this dimension can be related to tasks for music information retrieval. And that's what my PhD topic wants to do. We want to look at how embodied cognition can be applied to music information retrieval tasks in a practical fashion. So more specifically, I'm looking at the mechanism of cross-modal representation between music and gesture and how this relates to emotional expressivity, and whether using a deep learning network, a multimodal one, whether you can learn this representation. The goal of multimodal deep learning is to use data from different modalities to exploit shared information between them. And this is often quite hard because of the heterogeneity gap and the fact that you have data from different dimensionalities and they need to be consolidated. And this is usually done by projecting the data into a common subspace. Sure. So I'm going to quickly go through just some of the different methods for representation learning and fusion methods. So at the top we have the representation learning methods. So the first is the encoder-decoder, which is essentially translating from one modality to another. The second is coordinated, which learns a separated but coordinated representation for each modality under some constraint. The third is joint, which is essentially learning a shared semantic subspace. And then on the bottom there, the three main types of fusion for the data. So the first being feature level fusion, where you actually concatenate the features before they go into a single classifier. So essentially the model isn't actually multimodal. The second is decision level, where you essentially generate predictions for each modality separately and then feed it into like a linear layer right at the end. And then the third is model level fusion, which is somewhere in between the last two, where you concatenate the outputs of hidden layers. So yeah, for the purposes of my study, I've gone for the last in both cases, so using joint representation learning and attempting to use model level fusion, but this is always quite hard to do because you have to do some architectural voodoo. Yeah, so I'm looking at the moment at generating my own data set for this study, because I need three elements in the data set, which is valence and arousal ratings for music, the music itself, the audio, and skeletal positioning data of people dancing to the music and it being temporally aligned. So yeah, at the moment I'm doing a collaborative study with Goldsmiths University, with Chloe McGregor, who's the person in the picture. And yeah, the purpose of the study, really, I have to explain, is not to make a motion recognition system in order to beat state-of-the-art mechanisms. It's to really try and learn an embodied representation. So rather than comparing a model once trained against state-of-the-art models, most of which, or a lot of which, are multimodal but use lyrics as a second modality, I'm going to be comparing the precision and recall of this model once it's trained in a unimodal case. So after it's trained, I'm going to be feeding it unimodal data and comparing it against a model that has been trained only on unimodal data, raw audio, to see purely what the difference is in the representations that I learned. So yeah, my current approach is using an auto-encoded network. This is mostly because I'm yet to have a data set which I can train on. So this allows me to use a data set with only two of the elements, i.e. the movement data and the audio. And then later on, I will use the encoded portion of the network to predict valence and arousal values. And I'm currently looking at, in the future, using graph neural networks, not because they're the cool thing to use in deep learning at the moment, but more so because, human skeletons are naturally in the form of a graph, and it makes a lot of sense to leverage this representation. And also, graphs can be actually used as graph neural networks can be used as a fusion method, so you can represent the outputs of hidden layers as nodes in a graph, and then learn a trainable weight matrix between the nodes in order to actually attend to more important parts of the multimodal information. Yeah. Thank you.
And also just another reminder for the other presenters, the sound is important for the live stream, so you should please make sure that you either you're either close to that microphone or hold this microphone so that the people on YouTube will hear you nicely. Yeah, or this one, like it's up to you.
Okay. Can you hear me on Zoom? Okay. Does that? Yeah, it's coming up. Hopefully the.
Okay.
Hopefully the sound works on the computer. We'll see.
Yeah, I guess you need to turn up the HDMI volume or if you haven't done so.
The sound.
Because
Yeah.
the first one had a little bit.
Now, if you choose the HDMI output now, you should be able to hear it. Sure.
Yeah, we'll see if it. Don't know if this is. That's not it. Oh, I'll just point the microphone at Philip.
Okay, so next up we have Alex Starkovsky, who will talk about embodied beat tracking with a virtual quadruped. So please, Alex.
Thanks, Kira. Yeah, so I'm Alex. I'm working here at Ritmo, and I'm going to talk a bit about dancing robots. So this is a screenshot from a Boston Dynamics video. This big robot company, and so they've they've recreated with robots the video from "Start Me Up" by the Rolling Stones. And in my opinion, I don't think the robots dancing is very convincing. At least compared to Mick Jagger, and to me it seems like the robot is obviously programmed to move from point to point in some smooth way, and whereas Mick Jagger, it really looks like he's feeling the beats. I recommend watching it because I think it's quite interesting. But anyway, what I find more kind of compelling is these older Boston Dynamics videos where they've got some engineer kicking this poor robot on some like icy gravel or something, and it's really struggling to stay upright in this very lifelike fashion. So what I'm interested in is, what if instead of like engineer, we've got some music kicking the robot, and it's trying to absorb these kicks. And the way that I was thinking this could work is using self-organization. So the walking of this robot is governed by a circuit called a central pattern generator. Or at least in vertebrates it is. I'm not sure how these robots work, but how we, bipeds, quadrupeds, how our movement is organized is using these neural circuits called central pattern generators in the spinal column. And so I was wondering if this can self-organize to absorb these kicks, and then in that way synchronize, and then it would be moving to the beat. So the approach was using an evolutionary approach. So first we used a spiky neuron model, and the reason for this is because the biological neurons have this property that if you increase the inputs, the frequency of the firing changes a lot. And the idea was that this is probably crucial. Then we evolved in 2 stages. So first, we evolved the central pattern generator, which is the screen part, and this is 4 limbs, so 12 neurons in total, with 2 motor neurons, A and B, and a interneuron for each limb, and they're organized with mutual synaptic connections between them. And then using genetic algorithms, we evolved this part for flexible speed and movement direction. And then the second part of the evolution, we put in isochronous pulses and evolved this second layer, which is kind of like a recurrence hidden layer. You could see it as a recurrent hidden layer. And that organizes the inputs and distributes it to the central pattern generator. And evolve it for entrainment. So for maximum match between the inputs frequency and the walking frequency. And and there was also vestibular feedback. So this was the only part that's not open loop. And so feeding back the body tilts back into the circuit, not so it could stay upright. So this is what it looks like. Let's see if this works. So we have this drive parameter that's applied to all of the neurons, and that kind of controls the walking frequency. That was 102 BPM and 120 BPM. We can handle both of those. And then you can see it adjusts very quickly, and it also relaxes back very quickly. So that was nice. Whoops. We'll go to the next slide now. Okay. So I've been analyzing how this the entrainment performance. I don't know how much time I've got. 1 minute. Okay, and so as a function of complexity, so this is using like some pop music loops of different rhythmic complexity. This is quantified using an entropy measure. So 16 different samples. For the more isochronous kind of 4 on the floor kind of beats, it does quite well at sticking with the to the beats, whereas the more complex ones it can't really entrain. So that's and now I'm also trying with the hexapod, and that's not working as well for some reason. It seems to be more chaotic, and that's why we get these very dark patches where we don't measure any consistent frequency. So that's a proof of principle of this kind of embodied approach to entrainment, and it's quite a simple, small model. So next we're going to try to look at multiple interacting robots and see if we can generate things that, see if more complex kind of movement patterns can emerge from that. And I'm also interested in if these movement patterns can be learned over time, and then we can get things like social learning, which I think is quite interesting. All right, thanks.
Shane, can you hear us?
I can, yeah.
Okay, good. So, speaker. And we see Shane. Nicely. Good. Okay.
Great. So I just got, can you enable screen sharing there so I can share my screen?
Right now.
Okay, so yeah.
Just one second. Can you hear Kire?
Can you hear me, Shane?
Yeah, I can, yeah.
Okay, great.
Okay, cool. So I'm going to share my screen here now. Okay, great.
Okay, that seems to work. So,
Okay, super.
So then we'll welcome Shane Byrne. He has the presentation with the title of Enacting a Musical Habitus. Here deviance is possible. So please, Shane, go ahead.
Okay, so first of all, I'm very aware of my time limit here. I'm going to kind of contextualize my work and my research. I got very interested during my PhD in composing with my body, kind of stepping away from the laptop. I felt it to be more of a fluid interaction with the musical materials. So that's kind of the context of all this kind of work that I'm going to present to you, is within using my body, specifically using the Connect to map my skeletal structure, and then use that information to control musical parameters. So the first kind of the first steps of this were to use the Connect in this piece called Kinesia, and what I was doing was I was having a very open-ended system such that the composition was quite indeterminate. There were kind of there was a general sense of direction, but maybe you can see there in the second system there of the score, that was actually in this particular piece, the performer loses all agency and the compositional engine takes over the musical events, and the composer can then just react to the musical events that happen and manipulate the sounds after the fact. I was very interested in this whole kind of exploration of performer and compositional system kind of interacting in this way. And you probably notice some of these sound producing actions, sound modifying actions. They're probably very familiar to many of you there in Oslo. But these were the I guess the abilities that were granted or afforded to the performer at the time. The problem with this was it was somewhat amorphous. It was a little, like I say, indeterminate. I'm coming from, certainly with my electronic music, I'm coming from a fixed media where everything is very much more prescribed. There's much more definition in the structure. So what I tried to do then with subsequent pieces was to impose more of a structure. The problem with this being that I made too much of a constraint for myself. So some of these pieces were very strict finite state machines. So one event would happen followed by another event on the condition that this event had taken place for at least this amount of time, and such and so on and so forth. So what I ended up doing was kind of stepping away a little bit and wanted to have a bit more fun with my system. So I started working with a friend of mine who I played music with him for about 15 years beforehand in different guises, and this was the opening gambit. I know this quote was the opening gambit because there was another colleague of mine, Dr. Mark James, was doing his PhD thesis at the time on how habits are formed and the conditions that are necessary in order for a habit to be kind of solidified and concrete in someone's practice. So do you want to do some wild shit was the gambit that I offered this musician, my colleague Roar Connolly. And what we were doing was we were going to just do something, and we didn't know what it was going to be, just something out of our own comfort zone, using augmented instruments, again, using the Connect to track my skeletal structure, using real-time DSP control via this glove that I made for more accurate discrete control. I was using the Connect version 1 at the time. So, reliable, discrete musical events sometimes were not so reliable with solely the Connect, especially with stage lighting and stuff like that. All the synthesis then took place within C-Sound. So as we were doing this and as we were on this journey, we were conscious of we were able to build upon our pre-existing musical relationship, which is something I hadn't had before when I was collaborating with others. We'd already kind of seen our faults, our musical faults and our musical shortcomings. We had nothing to hide really, so we could have a bit more fun. So this history of collaboration affords some element of play, which I found had been lacking from some of my academic work. We also had this kind of shared aesthetic, you know, so we knew what we thought might be musically apt. Because there was no framework as such before we entered this composition, we kind of had to invent some sort of linguistic shorthand. These were musical touchstones, such as we'll play the section that's like Brian Eno now, or we'll play the section that's like Autechre now. Then we also got into using automatic pair references, such as describing the sounds you know, that we were creating with our mouths, because we were coming again from different traditions. And what these ended up being were these milestones around which we could base all our musical composition around, and we would meet them. We'd meet these milestones through different routes each time we played it. This is the kind of, you can see the score here now. I'm going to kind of burst on a little bit, and I'm going to play you a short section of this because, as the man says, you know, talking about music is like dancing about architecture. So I'm going to play a quick excerpt of this piece here. I'm actually conscious of my time, so I'm going to skip on ahead here. So this is kind of the crux of why I wanted to present here at this conference. All of this was really just a finite state machine approach. It's all built on conditionals and it's all hard coded. Looking back on our documentation, I can see there's huge gaps of when we're not playing music, when I'm trying to code in some gesture into the system. So what I need to do is I need to move forward with this compositional system and incorporate machine learning to recognize gestures, to maintain a fluid evolution of the composition system, and also to allow us so that it's an invisible agent within the compositional system as well. And so hopefully after this presentation, I'll be able to discuss some of this with you, and maybe some of you that are better versed in this area than I will be able to suggest ways that I can incorporate machine learning into this compositional system. Thank you very much for your time.
I think, Marco, you can just take over.
Hello.
Okay, great.
Hello, Marco. So
Hi.
are you ready for presenting? And I think you now also have share screen permissions. So, so next out is Marco Donnarumma with the title of Transgressing the System, AI and Corporeal Knowledge. So, so Marco, just please go ahead when you're ready.
Yeah. Looking for the windows to share. Here it is.
That looks
All
good.
right. Cool. So hello everyone, and I'm so sorry I cannot be there in person. I know there are a bunch of colleagues there that I've been knowing for a while, and it's lovely to see new faces within this emergent field. And unfortunately, I'm in Vienna working on a new production, so it was quite hard to come off of it. But at least I'm here, and thanks for having me and for the beautiful presentation. So I've got 5 minutes now, and yeah, so I'm Marco. I'm working as an independent artist and researcher. Started doing things in the early 2000s, got my PhD from Goldsmith 6 years ago, and been collaborating on and off with many people in that room, which is great. And right now I'm an associate researcher at the Intelligent Instruments Lab in Reykjavik. Now with this presentation, I'm gonna do something that's a bit less technical and more on the aesthetic side of things, so to say, aesthetic and experience-wise, so experiential stuff. And so during my PhD, I was working with Baptiste Caramio on different ways of using machine learning system for gestural music and augmenting embodied interaction in music performance. We ended up doing some really nice work, but everything was really disembodied. So software running on computers, and all the focus was on my body as a performer, which is cool, but also kind of limiting. And so after the PhD, I started collaborating with a neurorobotics research laboratory in Berlin, which is called Neurorobotic Research Laboratory. And I started familiarizing with this similar technology that Alex was discussing earlier. So these central pattern generators that use can use different kind of neural networks to drive motors that make up machines. And so I also started working with various designers and engineers in Berlin. And after a few years of research, we ended up making 6 prostheses. And the one you see here, it's called Ray, and it's a fascial prosthesis, which means I put it on my head. And it has 5 motors, and each motor is driven by a small neural network, and all the neural network influence themselves and the others. So this is me wearing it. And so what I was trying to do here, basically the central pattern generator create movements for the prosthesis, which can move on only 2 axes by choice. And but the real main point of interest for me was to put this thing on my body. And as you can see, it blocks my frontal view, and it just allows a bit of peripheral view. And because it moves by itself, I have to adjust my own movement as a performer on stage in order, well, not to fall and destroy everything, and do what I have to do in the choreography, and also try to have some meaningful interaction with the machine. So the way that happened is basically I programmed some kind of very basic haptic sensing for the machine. So it perceives different consistencies of what it touches, but also it can understand different ways in which it is manipulated. So if it's pulled, if it's pushed, if it hits something or not. And in this way, it changes behaviors. And all of this it's not pre-programmed. So what I programmed beforehand is just this very basic sensory motor system. And then the machine, with many quotes, improvises as a basic level. And I improvise with the machine, which makes very interesting for kind of an awkward interaction between a human body and a machine. And so just in closing, a couple of minutes, wanted to show a little video so you can see it moving. And I will say a few words about that. So sharing. There it is. Yeah. So this is quite an interesting way of performing, because I program the machine, I know what its behaviors can be, but I can't really say what it will do at a certain moment. And I do know that what it will do depends on what I do, and which makes for quite an interesting layer of interaction. And now why I entitled the talk Transgressing the System is because all of this stuff is pretty unconventional, and it's designed to, the system and the machine and the choreography is designed to actually go against a certain criteria for prosthesis design. As you can see, this thing really does not aid me in any way, but it actually takes away from me. And by taking away something, then it forces me to look into different connection with the machine in order to sense the stage and perform. And very small example, and then I will close. So one way that I learned by training that allows me to interact meaningfully with this machine is to understand the vibration patterns of the motor. What do they mean in terms of machine behavior? Because I feel them on my face. And so because I can't see anything, I just concentrate and try to entrain with the rhythm of the machine in order to understand what the machine is doing and what is in front of me. And that would be it for me. I can stop sharing. Yeah, there you go. Thank you.
Thank you, Marco. Next up is Mojtaba Karbasif from Ritmo, who is going to talk about his robotic drummer with embodied cognition. Are you ready, Mojtaba? Yeah. Please go ahead.
Yeah, hello everyone, and I'm Mojtaba, and I'm a PhD student here at Ritmo, and I'm going to talk about a drum robot that I've been working on during my PhD, and I'm going to address some questions regarding embodiment and embodied cognition related to robots and a drum robot. Okay. Let's start with a Turing test. I will play two drumming examples. Let's see if it will be played or not. Where is it? Oops. Yeah. Okay, this was the first example, and the second example is this. who thinks that the first example is a robot? And who thinks the second one is a robot? Okay, looks like pretty the same number. But yeah, the first one was played by a robot and a robotic drummer. And the reason I wanted to ask you or test this Turing question, simple Turing question here, was that with looking at the output of the robot, or kind of the function of a system, it's really hard to recognize what's going on, or how it is made, or how it is performed. So during my PhD, I was always thinking about this question that, okay, how could we make a robotic musician rather than a perfect performer? Like, are we going to build a robot that plays better than humans, or are we going to explore the possibilities with a new system and with a new body to perform, or to make new things with this new body? So as you know, that the body of a robot is completely different than human's body, and especially the control and the actuation system is basically different. The way that the neuromuscular system in human's body work is cannot be easily mapped to a robot. So instead of using humans' perspective or humans' perception of movement and performance to design a robot or train a robot to play drums, I was basically thinking about how I can make this robot find its own voice. Like, okay, I would have my own voice, that I am the robot that plays drum in my way. So that's a very basic question and fundamental question that I've been exploring during my PhD. And yeah, I've been trying to build these robots with kind of good mechanical functionality, with like a flexible gripper and springs and different springs and sort of actuator. But the important question, and I'm exploring, is this way that how we can use these robots to have their own embodied cognition. So to just briefly show, it's really hard to go through the details in 6 minutes, but just to briefly show the idea, or how different approaches can lead to this concept of embodied cognition, is the difference between certain approaches in training control models. So in a very classical way, we can train a network that is based on a data set by a human drummer, or probably the robotic drummer, and we just train the model and just give some drumming targets for the robot and evaluate if the robot is meeting the targets or not. In another approach, we can also use an interactive architecture that the robot interacts with the environment and gets some reward feedback from the environment to find the suitable ways of movement to reach the target. But again, in this approach, we need the reward from the environment to teach the robot what to follow or what to find. So again, it's kind of the classical way of following the human's performance or following the what is going on in the environment. But if we want the robot to have its own voice or have the possibility to explore its mechanical or physical capabilities, we need a system that has its own prediction of itself, like an internal model that is always trying to find new patterns by doing different actions. So this is what I call a robot with embodied cognition that is not following a certain reward function or a certain data set to be trained, but it's interacting with the environment to find its own voice or have its own cognition. So the robots are set up for demonstration in the remote meeting room. So after the session, you can go and see the robots working. But yeah, I would be happy to discuss these ideas during the panel and everything. So, and yeah, thanks.
So we have, yeah, we have this, and we have this that they can exchange this, and this can go to the.
Okay, that was a lot of interesting topics in one session. I think maybe Mojtaba ended it nicely with this, how can the AI or the robot find its own voice? And I think, at least in Marco's abstract, he mentioned about this, like now AI systems are very much about recombining existing content and imitating existing content. So kind of how can the AI find its own voice in this context? I think it's a very good question, and I'm wondering if you have any perspectives on that. So of course I know Mojtaba has opinions, so maybe any of the other panelists maybe want to start, since Mojtaba just talked, or anyone in Zoom as well, of course. Maybe Tejaswini, you have something? Yes. It looks like you have.
I guess, well, firstly, because it corresponds to the idea of the talk, which is about being domain-specific in a thing that culturally is pretty well defined, and therefore any AI building on top of it will have to be constrained with the same aesthetic and social notions of categorizing musicality and otherwise interactivity and so on, that the music itself holds and tries to preserve. And I think in as much as we try to use tools to kind of free ourselves from the things that we are unable to think of from training as people in a domain. The AI itself comes with kind of exactly the same baggage in a different way. Kind of. I don't know if that makes sense.
Yeah, thanks.
I can just remark on that bit. Yeah, I think that's quite interesting because in principle, we can in the future make like totally autonomous robots or systems that do their own thing. But there's still some bias due to us because we will stop if we stop finding them interesting, then we'll stop engaging with them. We'll stop looking at them, and so there's always going to be this human social and cultural biases, no matter how much autonomous kind of or intentional capabilities we give artificial agents. Yeah, that's enough.
Mark or Shane, do you have any comments on this topic? Marco?
Yeah, sure. Yeah, you hear me?
Yeah.
Yeah, I mean, I think it's a very good question that it may seems more practical in a context of robotics, but as you were suggesting, I do think it relates to the larger fields of AI. And I think it's also a matter of applications, no? So if you think that one of the biggest market for intelligent robot is the meat cutting industry, like there isn't really much discussion there about how and what these machines should learn. But here we are sitting at this music tech experiments mini symposium, and this is the place where I think it's very important to explore these ideas in terms of how do we working in certain fields that have to do with creation, with movement and music and art in the end. How do we envision this system to work? And I think it's important to go against what we or the society will even expect from machines, because we are all playing into the hands of a certain kind of cultural and political regime, no? And industrial as well. So it is in our power because we have the competence and the skills, and fortunately in this case also the institution to back up work that researches different ways of using these machines. And I think as we've seen in the last presentation, like you were making very good points, like why a robotic machine should play like a human drummer, because in the end, even if it plays as close as possible to a human drummer, it will always play like a robotic one. So I found very compelling your point that like machine has to find its own voice, and I think this can be applied to all AI systems that we work with.
Yeah, thanks. Moshtaba, do you want to comment?
Yeah, I guess that's a very important point to follow, and especially when we are talking about creativity, that's always hard to evaluate the output in a way, and that was the reason I tried to have a simple Turing test in the beginning of my presentation that show that it's always hard, or sometimes it doesn't make sense to just look at the output or look at the behavior and ignore the process or ignore the way the certain behaviors are emerged. And in my work, I've been always inspired by human psychology and humans, the models of humans' motor control and motor learning theories. And in my understanding, there is no perception or cognition without body. So if we think about an AI that is just processing information, we cannot expect some sort of agency from this AI. This is a very general opinion about this, but in my understanding, the notion of agency always comes with body, and if we remove the body, it's always hard to I don't know, give identity or give this agency to the machine. Yes, especially the Marco's work is really, I guess, contributing a lot in this way. I know that also Chari has been working with this notion of agency with AI machines, and that's also very, I guess, a question that we are always trying to explore.
Definitely,
in this kind of works.
Thanks. How much time do we have, Charef? Because now we're at the...
Yeah, we can go a little bit. We can go for like 9 more minutes maybe.
All right, yeah.
So because it's a nice topic and
many things to discuss. Yeah.
Crowds very excited waiting for that.
Yes, please.
All right. Thanks everyone for your talks. Hello, Marco. It's good to see you. I have a quick question. Did you notice any mutual influence over the years while you were performing with your machine? Did it also change your performative movements over the years while in your during your performances?
Yeah, thanks for the question, and nice to see you too. Yeah, so I made that piece that I showed in the picture in 2018, and we're still touring it today. So yeah, that makes 4 years and something of training with the machine, and definitely there. Well, it's hard to verbalize, but if you play any instrument, you know that at some point your body learns things, and it learns also to coexist with the instruments. So in this sense, it is very similar with a machine. It's just that this machine moves a bit more than a musical instrument, and I think it did definitely drove my choreographic thinking into different directions that I would have not decided to explore if it wasn't for this thing on my face. And that on one hand. On the other hand, I think it also it makes very interesting an experiment into gazing a bit into what kind of perception this machine has. And of course, again, I say perception in many, many quotes, because it's an extremely basic form of perception. But the moment, you know, I touch my partner with the tip of the robot to check where it is, and you feel that the machine reacts in a certain way, then you start understanding that there is something there that is working on its own. It's obviously not a human, or better, it's not definitely an animal agency. It is a sort of machinic agency, but that's indeed where your question becomes very interesting, because then how the agency influence, how this computational agency can influence an animal agency, that is mine as a human animal. And so, yeah, I think to summarize it, it is both an influence that happens at a very physical level, through sensory motor system, mine and that of the machine, that we need to interface with one another. And also when it doesn't work, that's also the most interesting part, because as other people here in the room working with robots know very well, motors get worn down the more you use them. In this sense, they kind of become old, if you want, metaphorically speaking. And the movements of the robot change, and therefore also the perception of the robot change. And these motors are actually quite expensive. You don't want to change them for each performance. So between one performance and another, in 6 months or whatever, the performance of the motor and the machine changes. And this requires you as a performer to adapt, understand, and play with a new behavior of the same machine every time. So it's really nice in terms of learning through physical experience and sensory motor practices, and also from a computational analysis point of view, it makes for quite an interesting case of how you don't really need like huge models to make something very complex and evolving, especially if you take into consideration the materiality of these machines.
More questions from the audience?
Hi, thank you for the inspiring talks. Özgü from IFI, but I'm coming from the technology side, so I was just wondering, in your work, what is the bottleneck? Is it the robots? Is it the sensors? Is it the AI? Is it the human factor? I was just curious, what do you need to kind of do your work better, or what do you need that something that works better, that will, in the end, your experience, your work, and what you output would be better? What is the bottleneck?
Who wants to start? Remy, do you have some in your work?
Definitely for me at the moment, it's having a data set.
Data set?
Yeah. The problem that I've had for a long time is there's only data sets which have 2 of the 3 elements which I need. Another bottleneck, I guess, for me is the actual representation learning mechanism. It's very difficult to understand how exactly to fuse features in a multimodal network in a way that isn't just result-orientated, in a way where you're actually learning representation, which is more analogous to human multimodal or cross-modal perception.
Thanks. I think Shane hasn't talked yet, so do you have some perspectives on this? Bottlenecks?
Yeah, for sure. For me, anyway, it was certainly sensors. More sensors added potentially more, control over the system. But then I would find that you get this co-articulation tripping itself up as you go along. So what I ended up doing was, as I developed different interfaces, say the glove interface, I stripped back all the sensors I could. And I guess the goal for me was to get as much expressivity out of very little. And it streamlined the system, and it allowed me to spend more time, let's say, creating music as opposed to coding or fault finding within my sensors. So I guess certainly streamlining my sensors was something that I needed to do in order to get rid of that bottleneck of sensors. Yeah.
Else? Tejaswini, Alex, yeah.
I think apart from data sets, representation and sensors, I think another problem is kind of finding a midpoint between too much and too little. A really sparse network sometimes gives enough to work with, and just keeping on adding sometimes doesn't work. And at other times, especially in multimodal data sets, there's the kind of acute awareness of sparsity of both data and representations themselves. But I think there's a third thing that's missing in between, which is kind of a way to translate from what we know are affordable rules in the domain into kind of where in the machine you can place them. I think that's like a thing that is a struggle. Yeah.
Yeah. Thanks. I think, unless anyone else is burning to say something, that we have to stop. But please continue discussing in the breaks. And thanks again to all the speakers.
Yeah, thanks a lot for both physical speakers and people on Zoom. Before we go to break, so today also we have several demos around. But this time we have 2 demo stations here, but also when you take the stairs down on the right, then on your right there's a corridor where there are 2 rooms where you will find 2 other demo stations. Room 217 and room 210. And here, there. So just please explore around. And we'll be here back in 15 minutes or so. Okay, thanks a lot. Session is about to start, and this one is gonna be, the theme of this session is creativity and expressivity, and the session is gonna be chaired by Nanette Nilsen from the Department of Musicology, University of Oslo. And stage is yours, and enjoy.
Great, thank you. Welcome everyone physically in the room, and welcome to the artificially intelligent, virtually embodied space out there as well. So as Shara just said, this is thematic session 4 on creativity and expressivity. And yes, my name was mentioned. I'm Nanette Nielsen, associate professor at Ritmo, working in musicology and philosophy. So I'll be chairing the session. We have the same system as before, which, as you, most of you, if you've attended so far know, is called the 666 system. 6 minutes per speaker, 6 speakers, 6 slides. Our first speaker is ready, Teresa Pilinski, who will be talking on anomaly detection as a means of sensing subtlety and nuance in musical gesture, toolchain, and preliminary results.
Is it here? It's here. Here, right? Okay. Hello? I don't think it's working. Okay, hi.
Make it close to your mouth.
Thank you. It's not going to be preliminary results. It's a work in progress. I had to update the title. Hope that's okay. So I'm Teresa Pilinski from the Augmented Instruments Lab at the Center for Digital Music at Queen Mary University of London. And I'm going to be talking about anomaly detection and so on. First, I'm going to be talking about the pedal box. The pedal box is an instrument I really like. It's very elegant. It's very simple. It's basically a box with some pebbles inside and a contact microphone. And I really like it because it has this richness in interactions. There's so many things you can do. You can take a pebble, hit the other pebbles, or just like move your hand around and with the pebbles in between your fingers. And there's many kind of gestures you can do, right? So there's great richness in gesture there. This acoustic mic, this contact mic, it's capturing, there's some DSP being done there, and the collision amplitude and the collision spectral content is captured. Let's think a bit about the interaction bottleneck in the pedal box. I'm taking the ideas of interaction bottleneck from this paper from Jack et al. That I really like. So as I said, the pedal box, it has a wide range of gestures and actions. And it has this bottleneck of interaction, so how we go from the physical gesture to its digital representation. That is what I'm calling the bottleneck of interaction. And we have this wide range of this richness of gesture, and we go to these 2 parameters. We have these 2 parameters that we send to the sound designer of our instrument. That can be ourselves, of course, but we have these 2 signals that we pass to the sound designer. And I get it, the pedal box, the interestingness of it, and what I like about it is its simplicity, it's how elegant it is. But I wonder if we could make this bottleneck wider. Is there any way in which we can leverage this richness of gesture and get some more signals, a bit more, signals that have a bit more of interestingness that we can send to our sound designer, that we can pass to the sound design, maybe a bit more signals, but also signals with more like interestingness in it. I don't have a word yet to talk about what I mean by this more interestingness in it, probably a more integrated representation of gesture, more subtle, more nuanced, but it's still in the air that. So widening the bottleneck, the interaction bottleneck. My first idea would be, let's just add more sensors. Something that we typically do when we add more sensors is just say, okay, now I have 20 sensors, I have 20 signals, I'll just send my 20 signals to my sound designer. And whilst this is an option, it's not really what I'm looking for, because you just end up in this like very high space of parameters in which it's very hard to play with intentionality. The notion of control gets dissolved in this like large space of fair enough, you keep the richness of gesture, but you lose a lot of intentionality in what you're playing in this process. Another thing you could do is associate variation of a parameter to each of the sensors. We have a name for this. It's a keyboard. We could just change the pitch. But again, there's something that's lost. Suddenly, the regions in the pebble box, each one of the regions acquires some meaning. So the gestures that I was doing are not the same anymore. Each position in the pebble box has a specific meaning. It's not really what I want. I want to preserve that richness of interaction. Adding more sensors also adds two main problems. First of them, redundancy. These signals, I'm kind of hypersampling the space. These signals are going to be as pictures of the same thing with very little variation in position. So there's only this bit of things that change in the signal from its position, right? So there's a lot of redundancy between these signals. Also, in those signals, there's a mix of things that I'm interested on and things that I'm not that interested on. I'm interested on the interaction, on the gesture, but I'm not that interested in maybe crosstalk across signals, again, this redundancy, or maybe some acoustic behaviors of the box. I just hit the box twice, and in the second time that I hit it, there's the acoustic result of when I hit it before. There's lots of things going on that I might not be that interested on. And how I've been thinking about this, and this is a metaphor from my supervisor that I really like, it's about distilling sensor signals. So you have this kind of impure liquid of signals. You have the 20 sensor signals, very impure, lots of things being mixed. And I want to do this kind of process of distilling in which I get the signal that I'm interested on, the more like essential interaction or something like that. Again, I still like the vocabulary to talk about this. But yeah, distillation. I want to widen this, get a wider bottleneck and get more and more interesting signals to send to my sound designer. In practice, how we've been thinking about this, it's using anomaly detection. So our idea is that if we can use machine learning or deep learning to predict like some the acoustics of this box, or like the normal states of this box, so how this box behave when it's not being interacted with. So for example, I hit it, and then there's some behaviors in the box that are acoustic, that are like inherent to the geometry of this box, right? If I could predict those states, then I could think that when the performer puts energy into it, when the performer hits the pebbles or does something with the pebbles, it's an anomaly. And if I can detect this anomaly in its continuity, in its with its subtlety and with its nuance, I would be very happy with that. That would be what I would call a distillation of those signals. So a very basic idea of what I mean by anomaly here. So I could, for one sensor, I could just take a very short window of the signal in the sensor, I pass it through my model, it predicts how this sensor is going to behave, then I compare it to the actual measurement, and this difference is what I would call the anomaly. Very quickly, because I'm 6 minutes already, very quickly, I've been working on this is a work in progress. Very quickly, when we want to measure lots of sensors using Velas, because I want to run this on device and of course in Vela. It's not trivial to do this because you need to synchronize the signals if you want signals that are like frame-wise aligned. So I've been working with this Vela parallel com library that my colleague Adan wrote, and I wrote some wrappers on top so that you can record them. Record signals on various Velas, synchronize them, and then kind of load it in your PyTorch or whatever preferred framework. And that's it.
Hi, Charles.
I think it's me. Can you hear me? I hope I'm speaking. I'm unmuted.
Okay.
Wonderful. 1, 2, 1, 2. Yes, Charles Martin is on our screen, and we'll talk about instruments that push back manipulating feedback networks with embodied musical AI.
Could you just give me a wave, Nanette, to say that you can hear me? Okay, that's excellent. Thank you, folks. I'll try to speak quietly. It's going to be an ASMR version because, you know, the kids are asleep. So ASMR videos about instruments, the pushback. I've got my 6 slides here. I've got sneaking in an extra one just because it's traditional in Australia that we just acknowledge the unceded lands of First Nations people of Australia that we work in. And this is Canberra, where I live. It's land of the Ngunnawal and Ngambri people. So it's Ngunnawal and Ngambri country. And I'll just acknowledge the First Nations people who've looked after this land and stewarded it for tens of thousands of years. So in this talk, I'm going to talk about embodied gesture generation. Embodied gesture generation. And here's a little example of some embodied gesture generation on a typical 8 input mixing controller. And there's 8 little knobs, and they've got 8 little lights. And what's going on here? What's the difference? What's this generation thing that I'm doing with machine learning? Well, I'll just pose this by contrasting with note generation, which is normally about generating symbolic music or notes for any instrument, an abstract idea. And often in my work, I use this term embodied gesture generation to mean generating movements that a performer makes for a particular musical instrument. And in this case, the particular musical instrument is this mixing interface with little knobs. And so the generated gestures are the movements of these knobs, represented here by a little light. So the question here is, what can embodied gesture generation do for musical interactions? And I think it's interesting to think about feedback with instruments as a way to frame this. So I'll just stop talking about electronic musical instruments for a minute and talk about my other music I make as a percussionist. And this is a photo from an orchestral gig that I played a few weeks ago. It's not very typical for me to play percussion these days, but I happened to get a call, and I don't get that many gigs, so I didn't say no, to play in the big orchestra in Canberra. And I got to play the bass drum here over in the left-hand corner, 40-inch bass drum in a concert which had a lot of bass drum in it. I was whacking that bass drum like there was no tomorrow in this concert. I was worried I was going to break the skin because they kept asking for more. The conductor wanted more bass drum. When you hit a bass drum very hard, the skin moves, and it's moving and resonating and continuing to move in and out with quite a lot of force. So when you hit it again, the instrument actually pings your mallet away from the skin. So if you hit it hard and then hit it soft, you can find your mallet kind of working against you. And this is to say that instruments are not one-way operations. All musical instruments take gestures in and they give a sound output, but they also have lots of dimensions of feedback. And just to name a few, feedback is haptic, visual, oral. I'm sure there are other things I've missed, but just noting that there's always instruments pushing back at us, normal musical instruments. And we appreciate that. You get it when you muting a note on a guitar, when you're playing a violin, feeling the movement of that, and particularly as a percussionist playing quite large instruments that have a lot of energy stored in them when you hit them. So what less explored types of feedback might be possible? And for the next 2 minutes, I'll just go through a few little bits of speculative music technology thinking, and how could we use gestural embodied gesture generation in these kinds of feedback. So it doesn't want to play my video. That's really frustrating. I'll see if I can use my other browser. It worked until I started sharing. Zoom must be breaking something. I'm just going to stop the share for a minute and just share the full screen experience. I'm using Linux, computer scientists. What are we doing? Okay. Hey, there's my video. Cool. Okay. So the first dimension of things, I haven't optimized for video, so you'll just have to imagine so you can see it smoothly. But the first dimension that might be interesting is instruments that move. And this sort of relates to the bass drum idea. The bass drum has a moving skin, and it's part of my experience as a percussionist to cope with that. I developed this little instrument as a little toy, basically, called a a embodied music prediction interface where it had one dimension of musical input, one dimension of musical output with a little motor. And the idea with this instrument was to just experience some machine learning generated music, embodied generations, both through sound, through the little speaker, and through watching the movements of this little arm. I learned a lesson with this one, which is that I don't want to make robots anymore. I used to work at IFI in the Robin lab, and I thought I'd better make at least one robot, but never again. Too hard. Haptic feedback is difficult. A lot of electronics to deal with, a lot of stuff to deal with, but it's very interesting, and maybe there's a lot of other ideas that could be made with instruments that move. What about instruments that change shape? You don't expect when you walk up to a musical instrument that it's going to change shape under your fingers, but for a long time I've been working with touchscreen musical instruments, and I worked with developing apps that would actually change under the musician's fingers as they're performing. So if you're in a performance with other musicians, in this case it was an iPad ensemble, there'd be some software tracking something that's going on in the performance, and then the notes that you would have access to would change. So this was an app called Phase Rings, and you can see these little rings under the performer's fingers. There's me and some others. This person's got a lot of rings, but it might change and you only get 2 or 3. So you'd have quite dynamic differences in the interface, changing shape during the performances. What about instruments that take up space? They inhabit the world in some way. So I've been working a lot with augmented reality musical instruments with my PhD student, Yichen Wang, and she's been developing lots of different prototypes of how we could create musical instruments that make sense in augmented reality using these interesting ways of placing virtual objects in the real world, either with a visor and a kind of holographic projection, or with a VR headset with a lot of cameras on the outside that lets you superimpose reality over a virtual scene inside the headset. So these instruments can change shape, they can move around, there's lots of possibilities. And I guess the point here that I want to make in this is to be speculating about different designs that we haven't expected. What kinds of feedbacks could musical instruments give us? And I think that the embodied gestural generation, because it gives you this continuous control, continuous outputs, not abstract notes that we feel we need to process into particular sounds, we get more flexibility with this kind of embodied generation. I think it's interesting to try to map these outputs to different types of experiences for performers, and also for the other performers in a group. And this is where I get to feedback networks, the last slide. There could be embodied gestural generation models working not only with the individual instruments of the performers, but giving some feedback that others can see, even if it's not directed towards them. You can see it if an instrument changes shape, if it gets bigger or smaller, or if it moves around in some way. So you're providing more cues for ensemble, and I think that's something worth studying. And that is the end of my talk. Thanks, folks.
Okay, I think Kenrick, you can just take over.
All right. Hello, everybody.
Hi.
Wonderful. So we've got our next speaker ready, Kenrick Ho, drawing stick figures with music, reflections on using Lærdal's cognitive constraints for composition. Take it away.
Okay, let me just share my screen real quick. Okay, so hi everybody, my name is Kenrick and I'm a third-year PhD at the University of Leeds. So a little bit about myself. My practice-led PhD is broadly about exploring music cognition theories in the context of contemporary composition. So my music is very much inspired by the legacy of, James Tenney and John Cage. So the writing process tends to focus more on the conceptual level, and then I sort of try and experiment with audible perceptual processes. So basically what I'm working on at the moment is that I've made a generative machine learning algorithm to create musical materials for me. And then for every piece that I write, I work collaboratively with that performer to sort of figure out ways to embody this musical material in a way that sort of relates to this broader experimental compositional context. So for example, this can be done using, indeterminate notation, or by implementing some sort of process-based structure, or by using live electronics. So basically, in short, my thesis explores this approach where there's a joint effort between myself and my performers to sort of inject creativity, so to say, into some otherwise unembodied AI-generated materials. Okay, so rather than trying to rush a sort of breakdown of my project in 6 minutes, I thought it might be more meaningful to sort of talk about how I came up with the project, because I didn't wake up one day to decide that, hey, I'm gonna do a PhD on composer-performer relationship in embodied AI material. There's a lot of sort of trial and error and thinking from my previous projects that sort of led me to where I am. And I was hoping to reflect on these errors so we can avoid, or at least be aware of, these sort of potential problems. Okay, so in my first year, I started with a smaller scale project based on Fred Leto's article titled Cognitive Constraints on Compositional Systems. So Leto, in case you don't know him, he's a composer, also a cognition theorist, and he's probably best known for co-writing this very influential book in music cognition titled A Generative Theory of Tonal Music. And in short, his theory sort of aims to explain how listeners listen by borrowing from Chomskyan syntactic tree models in linguistics. But what's interesting here is that he actually tried at one point to reverse engineer this theory of how listeners listen into 17 constraints, which are supposed to theorize how composers might be able to compose based on his theory of, generative theory of tonal music. Just to have a better idea, here are some examples of what the constraints look like. So the first one states here that the musical surface must be capable of being parsed into a sequence of discrete events. And constraint 11 states something like the pitch collection should recur at the octave to produce pitch classes. So this mini project of mine from my first year aims to build this generative algorithm that satisfies all 17 constraints to test this idea of using a theory of cognition for basis for composition. And looking at constraints 1 and 11, this means that the algorithm avoided polyphonic writing to ensure having, discrete events in quotes, and functions in terms of equal temperament. So I should also mention that I have a secondary supervisor, Freya Bales, who is a music cognition scientist. So she was also there to make sure, the implementation of the cognitive constraints was fair to the whole body of study behind the GTTM. Anyway, here are two things I want to share from this experience. So the first one is an observation that Leto's theories, both the GTTM and the CCCS, are based on the idea that music, especially pitch, is syntactical, like in linguistics. Now, I'm not going to be sort of touching on this debate of whether musical syntax is cognizable in our brains or whether there are any sort of real parallels between music and language. But the fact that Leto's constraints concern only musical syntax means that he views composition as an activity that exclusively deals with an abstraction of pitch material. And what I've learned from this is that pitch really isn't what composition is only about. I ended up achieving by playing his game and achieving all 17 constraints is a bunch of this abstracted pitch material that has no embodiment and does not sound like anything like a piece at all. The materials are very unidiomatic to real instruments to play, and they're not even always physically playable. So basically, it still needed a lot more work between the composer and the performer to shape this so-called cognitively perfect piece into a playable piece, which is where I got this idea to explore this AI composer-performer triangular relationship in the first place. And so the second sort of observation here is that using a cognitive theory as a recipe for composition may not be as good as an idea as it sounds. So at least in terms of what I was initially hoping to achieve. So what I didn't realize was that there's a conflict of discipline implied in this project. Psychology, on one hand, seeks to explain human musical behavior with a scientific approach, whereas composition, on the other, uses a creative approach to find interesting musical results, right? So what I ended up creating by following this recipe of how listeners listen is a piece that fits all of the cognitive constraints perfectly, but it sounded, too nice, and it was just very uninteresting to me as a composer. So the pieces, basically, there was a melody, there's a harmony, it was notated as well, but they sounded just too basic and aesthetically neutral. And I would say it's almost like drawing stick figures, but in terms of music. So you can say maybe stick figure music is art, and I genuinely believe that there's bound to be people out there who likes this kind of very aesthetically ambiguous music. But in the context of my compositional research, especially with the tradition that I try and work with, I just prefer to try and act on it with my performer. And so this leads to my sort of project now, which is trying to enact musical interest, to embody this sort of stick figure style music from a very unidiomatic algorithm. So yeah, that's basically the path that led me into my research project. And so from the point of view of one of the composers in this human to AI triangular approach, I realized that treating pitch and abstraction may not be very realistic, but on the other hand, it's also very helpful in helping me notice what is missing in the AI. So this is basically the angle that I'm coming from, and I'm trying to understand this embodiment of AI material from a compositional point of view using this approach. Ooh, I think that was 6 minutes, and here's my bibliography. Any questions? Let me know. Thank you.
Now we're gonna switch to and I'm assuming I can do audio switch to mine as well. Yeah, exactly. Is volume control there? Yeah.
Wonderful. So I think we're ready for Mike McCormick improvising with an algorithm, a performer's perspective. Take it away as well.
Do it like this. 1 second. Yeah. This mic here.
Hey, yeah, I'm Mike McCormick. I am a Canadian composer and performer, improviser living here in Oslo. And I'm going to try and, I have some videos that I want to show, and there's not so much time, so I'll skip around very quickly. But basically in the last years, I've been working with interactive systems with different performers. And I'm going to present 2 of them here today. One that I started working on with a German vocalist in 2018, and another one that started developing this year. So what happened in 2018 was that Masha Korman asked me to play a concert in Switzerland, knowing full well that I was supposed to be in Canada on tour. And at the time I was doing like live coding performances with her and another vocalist, and so I kind of took the opportunity to, okay, maybe I can encode my improvisational approach in an interactive system, right? How hard can it be? And I kind of saw the opportunity as a way to get to know my own aesthetics a little bit better, to sort of see how is it that I listen, what is it, how do I make decisions when improvising, and are these things that I can sort of, encode and sort of make reproducible in a way that's sort of consistent but surprising and interesting. So this is a short excerpt from a concert in 2019. After we toured with this project, this is sort of near the end of the tour. Yeah, just a short excerpt, but the reason I'm showing this video also is because at the same concert there was another band playing. It was their first gig as an ensemble. Let's see here. We don't need to hear this again. A band called Meet Karaoke Quality Time. So this was their first concert in 2019, it was on the same day. And since then they've been developing their concept quite a bit, and this is sort of where it's at now. Lots of fun stuff there. It's 2 EWIs, 2 electric wind controllers, and electronic drum kit. So they can play whatever sounds they want, whatever sample libraries they want to use. They control synthesizers with the EWIs. It's this really diverse and complex sonic space. So they contacted me last year to see if I could design an interactive system for them, sort of based on the one they heard in 2019. So I worked on that earlier this spring, and then I went to visit them in Germany in June. And instead of showing the sort of musical outcome, because I think there'll be a release at some point and you guys can go buy the record or whatever, I did some interviews with both Florian from the ensemble and also Masha from the first video this fall, just to kind of get a bit of a deeper understanding of their experiences working with these sorts of systems, and also the process of developing them, which I think is, for me, was super relevant. So what I'm going to play is a bit of a longer video of Florian from Meet Karaoke Quality Time. A lot of the things that Masha said actually were sort of echoed by Florian, but there were a couple points that he made here that I thought were kind of interesting to share. So here's Florian Woltisch.
Like how I experienced, for example, robotic AI in the very first place in exhibitions and when people used it. It's sort of, yeah, it does something and it sort of responds to what I'm doing, but I have no idea, I don't understand the language at all. And like this time it was completely different because I could, like 100% I could understand the language. But also I think because you actually improvise you yourself as an artist, you do this sort of music and you're not limited, same as we, you are not limited to this sort of like, I do noise improvisation, you know?
Yeah.
So I think that's a huge, that's really a huge factor, sort of like your own background. Because like all the people that I know that work with like self-programmed AI systems, they are only doing this sort of like, yeah, very super abstract noise improvisation on guitar. And
it's always guitar players.
Yeah. It really, I mean, like from after the on the end of the 3 days that we worked, for me it felt very much like a fourth player that was in the band for half a year or a year. So the band is existing for 3 years, and there's this one player that's in for 1 year. So there's still like it lacks the, how you say, like the physical. The consistency maybe a bit. There are these anecdotes and these stories from back in the days, and there is still this touring experience. Like, do you know when we, or do you remember when we've been in Spain and in this? You know what I mean? If it was a person, maybe there would be this sort of like potential conflict that is like 3 of us, and there's this weird other guy. You know what I mean? And I mean, we really want to play with him, but I don't know. Still, sometimes there are these misunderstandings. A bit like that, maybe.
And so because it's just a computer program, it's easy to, you can get past it.
Yeah, it feels pretty much human after all.
That's very wild, I think.
Like how I experienced, for example, robotic AI.
So I think the thing for me that was the biggest takeaway of some of the stuff that Florian said, and also things that Masha said in other ways, were that I kind of underestimated the social aspect of working in an improvising ensemble, that there's more to just sort of learning each other's musical vocabulary, which takes time to develop or time to study, but also this thing about the extra musical activities that contribute to trust and intuition and this sort of shared understanding and sort of shared aesthetic that is, it's something I have to think about going forward. How is this something we can put into interactive systems, and how is it something that happens actually in the code itself, or it's something that maybe happens in the process of developing them? I'm open for suggestions. Well, thanks.
Yes. Okay, let's see. Okay. Oh, and I can see actually. Yeah, that's and that's great. The main one is here. Okay.
Scale it.
I think I'm on scaler. Yeah.
Great. Well, thank you so much, Mike Cormick. And our penultimate speaker is Balint Lachko, who will talk about working with AI to create the world of the hum.
Okay. Hello, everyone. I'm Balint Lachko, a composer and software developer, and my focus is in data-driven composition, audiovisual analysis, and AI as in advanced information processing. I'm very happy to come here today and show you sort of the creative process behind building the world of the hum, my audiovisual live performance. So what is it? The closest metaphor I can use for this is a computer game, in the sense that it is a 3D audiovisual environment where the player can freely move around and explore the space and interact with the environment. Of course, it is also similar to a computer game in the sense that it is framed by a story that creates a certain narrative suspense. But our main focus today is on the sound dataset of the hum and how AI helped me to make sense of it and extend it, and in general how AI helped me to make informed artistic decisions. Here is a quick slideshow of some of the objects I sampled. With my first recording attempts, I immediately bumped into the problem of sizing. So the way I did it at first is that I just had this long, continuous kind of free improv sampling sessions in the recording booth, and then later I attacked the raw recordings with an army of slicers. And I guess this is a popular approach, and it had worked for me in the past in, for example, finding and manipulating grains in naturally grainy sounds. But in the hum, this approach did not work because it was not feasible to sound design thousands of short musical phrases from tiny grains. The more I worked with slicer algorithms, the more I realized that what fails in the live interaction is that it lacks articulation. It sounded all too mechanical. In the end, my persisting failure to design a perfect slicer that would always give me musically meaningful slices made me realize that I myself was not consistent with my slicing requirements, at least not on the level of music technology. So I decided to redo all the recordings, but this time framing the act of sampling as a performance where I deliberately made up short musical phrases with the objects. In post, I went through each and every recording manually and adjusted where a phrase should start, where a phrase should end, adjusted the fades, or even just discarded a recording completely. This going completely manual on the slicing problem not only solved the problem of getting musically meaningful slices, but also made me know my dataset really well. And this insight was very, very important to develop a meaningful, to craft a meaningful feature set for analysis. What is perhaps less typical in this feature set is that I also included actually those slicer algorithms as descriptors, counting the rate of grains, transients, or higher level spectral novelty. And this actually turned out to be really efficient in expressing relationships in sounds made by scratching, scraping, and rubbing surfaces. So another big inspiration for the hum was the implementation of the UMAP dimension reduction algorithm in the fluid corpus manipulation toolbox. And I immediately got into experimenting with it and with my 63-dimensional dataset that only contained a few hundred samples at the time. At first, I created sort of cut art like two-dimensional plots, if you know what that means. And I very quickly found that limiting, and although I only have 6 minutes, I can't stress enough how 3 dimensions is so much more than 2. So I quickly moved on to having a 3-dimensional representation, and this is exactly what you can yourself try out in my demo level downstairs. So with this, I was able to freely wander around in this audiovisual playground, exploring relationships between musical phrases of my dataset. This helped me to verify that the feature set made sense of my material and quickly demonstrated where, let's say, variance of my dataset fell a little bit short. But it also revealed areas where the phrases of different objects formed smooth bridges where I could swipe through them very easily. Spectral transitions. Come downstairs and check it out. So this exact morphing phenomenon gave me the idea how to go on with the further sampling sessions, how to choose new sounds or how to perform with them. It even inspired the finale of the piece itself. And as you might have realized, it also became the seed of the visuals. Instead of just sampling objects intuitively, now I had an objective to bridge the sounding character or the performances between distinct areas in this UMAP 3D projection. I had sampling exercises where I deliberately spotted 2 positions in this 3D map and listened to the sounds and tried to come up with like a gradual transition in terms of my performance to fill in the blank and bridge those gaps. And lo and behold, after I added the newly sliced and curated batch to the system, more often than not, the new points were projected in the areas that I predicted them to. Also, on the other hand, the whole shape of the point cloud of this UMAP projection shifted every time I added new sounds. So it was kind of an interplay between me and in the system. But I guess my final point with all this is that the whole process felt like a creative feedback loop where machine learning tools not only help me to make sense of my material, but also to make informed artistic decisions about the development of the work. Thank you very much.
Excellent. Getting ready as well. So thank you so much, Balint. And our final speaker, before we turn to the panel discussion, is Victor Shepardson. We'll talk about investigating. Oh, change title? Yes. I'll read it out. Using notochord and microphenomenology to investigate lived experience with statistical AI.
Hi. Hi. I'm Victor. I'm coming. Okay. Third try. There we go. I'm Victor. I'm coming from the Intelligent Instruments Lab in Reykjavik, where I'm a PhD researcher. And I have reconfigured my monstrous title to try and emphasize that this talk is about studying what it's like to be with big, like large-scale statistical AI using these two instruments. One is called notochord, which I'm demoing over there, and the other is the method of microphenomenology. So first of all, the statistical AI. We built this thing called notochord, which is one of these big deep learning-based generative models for MIDI sequences. And there are a bunch of those already, but what distinguishes this one is it's like polyphonic multi-track model that deals with individual events, and it deals with them with a very low latency. So you can hook it up to a MIDI controller, like the one in the demo over there, and intervene directly between your gesture and the sound. But at the same time, it can do a whole range of different things because it breaks each like node on, node off event down into pitch, timing, velocity, and instrument ID with the general MIDI instruments. So you can condition it on just part of that. Like you can say, I'm playing the velocity and the timing just on a pad, and it can fill in the instrumentation and the pitch. Or in any combination, you can just supply any of this information, have it complete it, or you can sample for completely different parts and have it play autonomously. You can kind of mix and match all this stuff. So in operation, it looks like this currently. You have like some controller, could be any controller. In this case, it's this keyboard and drum pads controller. I have like a synthesizer, fluid synth, just running the general MIDI sounds in a terminal. Another terminal is running like the notochord Python server. And then there's this there's a super collider program here, which implements the logic, which says, what are you doing with this thing that can sample all these MIDI events? Like the most obvious thing is kind of sample an event, feed it back in, and have it just generate a big slab of weird MIDI-like music. But much more interesting is when you do this kind of conditioning on part of a performance in real time. So we trained the notochord on the lock MIDI dataset, which is one of these very large datasets which contains more MIDI files than you could possibly listen to, and also gives a lot of fun stuff to play with, like you give the whole orchestra of general MIDI sounds. So it's a way of getting at what these large-scale statistical models feel like, which are, in one sense, kind of uncannily capable, but in another, extremely crude. They just give you this statistical distribution over the next single event. So to get at the what does it feel like part, I've been exploring the microphenomenological method, which, for those who aren't familiar, is basically this interview method which lets you produce these really rich descriptions of short moments of lived experience. So in the same way that, like, if I wanted to describe in detail this chair, I would have to stare at the chair for a while and kind of take in all of its qualities and find the words for them. This is just an interview method where the interviewer kind of focuses the interviewee on a memory and asks these very non-leading questions, but questions that always turn them away from tangents or whatever tangents or explanations back onto the concreteness. And you really pull out kind of an enormous amount of detail about how an experience unfolded across all your sensory dimensions, how one thought led to another, what was going on in your body, all these things. And it's been deployed in design adjacent fields, including NIME, in a paper by Taparo and Zappi at this year's NIME. So I just ran a brief pilot study to kind of smash these things into each other and see what happened and evaluate them sort of as a methodology. And I'll just end with a brief description of how one of these went. So I had a jazz musician encountering notochord, and it was set up as kind of a co-improviser. So the musician would play certain instruments on the controller, and it would sample autonomously from other instruments, generate other parts. And we were able to kind of zoom in on the sequence where the player hears a new chord and has this feeling of being unsure who's suggesting the chord, them or the system. And that's like the movement of the relative minor. Then they have this perception of a behavior of the model as deliberate after it's repeated a few times. So they're at first kind of skeptical, and then kind of develop confidence in it as it, demonstrates some kind of reaction to what's going on. And that's it, playing this minor third above the harmony. And then finally, there's this moment where they kind of relax and let the system take the lead as if it were another improviser. So the point is just that you can pull out a lot of these details. It seems like a useful method, good way to structure an interview for finding out, untangling these very complicated generative models and seeing what it feels like to encounter them in an embodied sort of way. And one final note, I guess, just I think it's interesting about the sense in which the system supports embodied interaction. There's one sense in which, relative to the other deep learning models, it brings you closer to the body. It's something that can feel like an extension of the body through the controller. In another sense, of course, it has all the limitations of MIDI still, and it's much less embodied than all this talk of robots and stuff. But then in another sense, like the more abstract sense, it's embodied in that it lets the statistical model become extremely embedded, kind of all the way embedded in the flow of musical events, and become really co-creative of them at the most fine-grained level. So that's what I've got. Thanks.
Excellent. Thank you so much, all of you. I realize we're competing with lunch. I've been told that we are allowed to speak and discuss until around 12:30. So what we'll do first is just have a panel discussion, and then we would like also to take questions from anyone either here or on YouTube. You can try and write the questions down as well. Okay, so I'll kick off. Thank you, everyone. What I'd like to do is to invite you to think through some of the human. Can you? Speaking of human, is my head too big for the screen? No, it's perfect. So invite you all, please, to think through some of the human inactive elements involved, and so. Think through some of the reception aspects in particular. And I'll just say a bit about why I was inspired to ask this question. So, for example, the Balint-Latsko that you mentioned, the creative feedback loop. So think about the opportunities afforded by the creative feedback loop. Or when Kenrick Ho asked the question, how listeners listen, I was inspired to think about the consequence and effect. How far do we take this? And seeing as Kenrick was sort of dipping into the 20th century, I was reminded of Milton Babbitt, who in 1958 wrote this essay, Who Cares If You Listen? To which we might respond, who cares if you compose? So there are sort of some human inactive elements involved. There are consequences and effects of this kind of creativity and expressivity. it was mentioned how there's this sort of in the construction, the need for human agency to enact musical interest from the algorithm, or Mike McCormick's idea of the social dimensions of musicking. So if I could start by asking that rather elaborate question. Who would like to go first?
You look like you're gonna go. You're going first.
Hello. Okay. In my case, I guess this is fairly straightforward because in this work in the hum and generally, I guess in my approach when it comes to making music or art with the use of machine learning or any sort of AI is really utilitarian, or like I haven't really been exploring this space of treating the algorithms as or interpreting them as agents with intents or goals, and sort of interacting with them to a peer-to-peer level. I'm much more into like how can the algorithm sort of teach something about what I am trying to do with my material, and how can it sort of enhance my composer cognition, if that's a thing. Yeah, I guess that's it.
For me, with the Note Accord project, I'm not really thinking of it as a social agent, and I guess I'm interested in kind of the alterity of it as this actually kind of crude statistical process, and the kind of ambiguity of it being a tool versus trying to appear like a musician. But this the kind of social expectations of another player, especially when it's set up to behave kind of like an improviser, is definitely something I've run into when running these pilot studies. I think this was mentioned in one or two of the talks yesterday as well. Like, there's just no way to, it doesn't telegraph its intentions currently, but I think it'd be very interesting to explore the ways in which it could, because it's always, you know, it makes every prediction the instant the last event came in. So there's this opportunity to develop like a different kind of social interaction between musicians and the predictive model.
Just sort of following up on that point, I think it's something that Masha said in our interview, which was really interesting. She talked a bit about how she needs to practice and train herself more to play with an interactive system. So there's something about, also I think in your research as well, there's a new audience sort of emerging of people who have experience with these systems, and a new sort of skill set emerging maybe in the improvisers. There's different expectations of how these systems are supposed to work, and maybe also maybe a lot of skepticism as well. And yeah, it's kind of an interesting, at least for me, I feel like I'm always confronted with surprising questions and surprising ways of talking about these things with maybe musicians who don't have the same shared vocabulary about the sort of technical aspects of it. It's quite interesting, I think.
Thank you. Do we have Charles? Did you want to add anything?
Okay, why not? While you ask me that, thank you. I guess in my experience, I feel like, well, following along from some of what we've said about interactions with other improvisers and machine learning systems, when I was studying the little moving wiggly arm box, the participants or people I was having improvise with that were just so interested in trying to work out what this was doing, what was the intention behind its movements. And when I was studying that, I actually presented them a model trained on noise, just uniform sampling positions for the arm. And there were some folks who sat down with that noisy random arm movements for many minutes trying to work out what it was doing, and just really trying to find out the intentionality of it, trying to work out what this is, how this is behaving with them. So I still feel like there's a lot of accidental anthropomorphism or something with these systems. People, and I perhaps see that in the, I haven't read the Node Accord paper, sorry, yet. It's still pretty new, right? But I see that in some of the ways that perhaps your improvisers have worked with it, looking for meaning inside chords or certain actions, not just taking them on their face value. Do you think that? I'd be interested in your feedback about that.
Any comments from the panel?
Sorry, can you repeat the end of that question?
So it's very late at night, so my questions are trailing off into late night ramblings. But when people find something interesting in Node Accord and look for how a chord or a new idea is taking them somewhere, do you think that they're seeing that on face value as equivalent to rolling a dice, or do you think that they're seeing it as something that is supposed to have, maybe has a second layer of interest in it? That they could ascribe to intelligence, right? Quotation marks, or a more sophisticated computational system.
I feel like we saw in the example that I described was this musician was initially treating it with skepticism, like this is a machine, it's going to do what it can. I'm not expecting too much. It does tend to behave a bit weirdly and randomly, especially if you start off with something surprising. So when gradually, over the course of after several minutes, really, of kind of probing around, they kind of identified something that made sense to them, that it kept doing persistently. They really had a change in understanding of what it was, and were willing, of course, like still with the exact same knowledge. And this was a colleague too, so someone who had already heard me talk about it, knew very well what this thing was. But they were able to kind of intuitively accept it as something that could take the lead in the improvisation. Like they found this moment they're waiting for as an improviser where someone else takes the lead.
Yeah. Do you think that that's because the system was good enough to do that, or because they learned how to work with it in a way that made them able to put it in that role?
It's hard to say. I'm not entirely sure what the difference is. Like I'm sure it's not really good enough to improvise. I would definitely say that, because it knows nothing about improvisation. It knows about MIDI files, most of which aren't recordings of improvisations, let alone situations.
Exactly. Yeah.
Yeah.
Yeah. Well, I don't know what that question means either, and I also don't know what the difference is. But here we are in a panel, so.
Yeah, that's what you do on a panel. That's true.
Thank you so much. It can lead on to talking a bit more about control, if you wouldn't mind, because in the creative process, it seems then that a lack of control might actually really be quite a beneficial thing, right? So you might be surprised about how the artificial intelligence speaks back. You can try the hum, right? That's a demo. So if you watched the teaser, I don't know how many were struck by how it was a bit scary. So maybe a question to you, Valiant, to think about this sort of idea of control and creativity, and maybe also even responsibility for the effect of something. So in the hum, lots of stuff seems to be left out for the player. Sort of lots of stuff seems to be left uncontrolled for the player or the participant. So the novelty of the experience rules, right? It can take you sort of anywhere. You talked about you can freely wander around, but then the effect may be less free. Have you had many people maybe trying the experience and sort of returned knowledge about that?
Yeah, so the answer to that is that the live performance itself, what you see in the teaser, is really something only I play. So it's and it also has like almost like a score, like a pretty well-defined narrative structure. And if you have seen the trailer or like the teaser, you also got a little bit of a sense of the story or like this. I guess a bit scary story behind it, and that is all like controlled, I guess, by me, the composer. What I brought to you here today, this audiovisual playground for like exploring and understanding your data set of sounds, is kind of what the embryo was before I even got the idea to make visuals or even to make a story for the hum. So it, I guess it was, I thought it was worth sharing this, that interacting with these systems can really put you in this loop where you just get more and more understanding of your material. And in the end, I chose to, you know, like set things pretty much in stone. And although there is a little bit of chance on the micro scale in the performance, but like overall, it's pretty clear and well defined. To answer to the question of whether like how would this work like an interactive exploratory system with others, well, I guess I came here to find out about that, and please come downstairs and try the dataset.
Finally, and then I'm going to take questions from everyone else. Teresa, I'm sorry. If we could just also touch upon control in your case, because I was really struck by the kind of potential frustration or the balance involved in having to, you widen the interaction bottleneck in order to get more and more interesting signals. How to make it wider, but then also, how still yield interesting results. And in the beginning of your paper, you talked about a bit of a conceptual possibility. And I'm wondering whether, if one takes hold of the concepts, if that helps sort of get control.
Again about the concept?
You mentioned a conceptual possibility, that there's something you said you didn't quite know what to call it yet. But yet, I was coming from the landscape of concepts as a philosopher. I was just wondering, to what extent can you gain that sort of maybe conceptual control, and what might that then do, in order for you to widen the interaction bottleneck, making it wider at the same time as sort of controlling the more and more interesting signals, but not too many.
That is a very relevant question, because it's what I've spent doing. I spent lots of time thinking about in my PhD. So my PhD is 4 years. I've been 1 year in. I just spent so much time thinking about what am I actually trying to do. Like, the idea is clear, right? Like, we have lots of signals and we're trying to get something that's more interesting than the possibilities we have already. But what does that mean? And this is just a rabbit hole. And I think I reached the point in which I am thinking like, I don't think I can squish more out of the conceptual space. I think I need to build it and then play with it and see, can I just train, 5 models and see how these models behave and how each one of them is pointing in a direction. And I think at some point you just need to build something and play with it. And yeah, I'm reluctant to think about agency of the models in my case, because I don't think I'm using it for this. I'm thinking I use it more as like a step in my process to build an instrument, right? But yeah, evidently it's a part of a design, and parts of design influence how the instruments get constituted, or somehow like how they influence how you play them in the end. So yeah, I think there's a point in which you just have to build something and kind of see where I am in a conceptual space, I guess. I don't have like a clear definition of what I mean by distilling, but at some point you just have to do the distillation and drink the alcohol and say, okay, that's good, or that's bad, or I would never drink this again, or yeah, this could make a good rum, I guess, yeah.
Absolutely. Thank you. So a few, we have maybe time for 2 or 3 questions, if there are any. People are hungry. Yes, down there, sorry.
Yes, thank you. This is about microphenomenology, and I was wondering if you were applying a specific version of it, or if you did train in microphenomenology, or if you're taking specific values that you're applying, because I know that it takes a long time. It's a very tedious method, but very detailed as well. So I think there's potential, lots of potential, and I love that method as well, but I think that there's some kind of tweaking that needs to be done to use it in contexts related to technology and the kind of interview context that we have usually in research.
Yeah, I completely agree, and I think this is something I probably forgot to say in my talk. I should more properly use the term inspired by microphenomenology, because I've only done partial training. And there is like a sort of accreditation process. It's sort of I don't know, a term with a community that prefers you to have gone through this training. So I've had some practical experience, but not enough to call myself an expert or like official practitioner of microphenomenology. And I think it's useful to kind of separate the sort of original research program for microphenomenology, what like its creator Claire Petit-Marchand uses it for, which is to kind of uncover the transmodal structures of lived experience. And there's this kind of peripheral literature where people have been using it for in design adjacent fields, where it ends up, I think, not really doing the deep microphenomenology a lot of the time, but it just ends up being this very useful interview method way of producing these very detailed descriptions of user experience. And then the other thing that's interesting about it is for like participatory design, it really provides a ton of insight to the people who are doing it. So if you're a user or you're an interviewer, and especially if you're switching roles and being both, it cultivates like a ton of insight, which can be applied in the ongoing kind of design process. So like not just data collection, but kind of a practice. But I'm really an extreme amateur in it as well, so just grain of salt.
Great. Any further questions? I don't see any questions on Zoom. Sorry, YouTube. Or Zoom for that matter. Okay, in that case, we can probably round off here and continue discussion over demos and everything. So please join me in thanking all the speakers for this wonderful panel. Thank you.
Thank you, Nanette, and thank you to all presenters. So I guess people should be hungry by now. So there's going to be lunch down at Ritmo. So for those who don't know, it's 2 floors down. So and we're going to meet here again for Sofian's keynote at 13:15. So in around 45 minutes. Yeah. Thank you, Charles.
Okay, I think we are getting closer to starting now. If everybody could come and take a seat. I think I'll also sit here in the front. So find a seat. This is always a good sign of a workshop, that people are talking and not listening to me. Okay, let's get started. So welcome to this. This is actually also a Ritmo seminar. We run Ritmo seminars once a month. And this time the seminar is overlapping with a workshop on embodied perspectives in musical AI. And I'm very happy to introduce today Sofiane Audrey, an artist, scholar, professor of interactive media within the School of Media at the University of Quebec in Montreal, UQAM. He's also co-director of the Hexagram Network for Research Creation in Art, Culture and Technology. Their work explores the behavior of hybrid agents at the frontier of art, artificial intelligence and artificial life through artworks and writings. Audrey's book, Art in the Age of Machine Learning, examines machine learning, art and its practices in art and music and was published by the MIT Press in 2021. Their artistic practice branches through multiple forms, including robotics, installations, bioart, and electronic literature. So, please give a warm welcome to Sofiane.
Thank you very much. I'm really happy to be here with you today. And like everyone here, I figure out that, well, I feel like an outsider, but I guess that makes me not so much an outsider since it seems like we're all outsiders here from what I ended up telling, looking at all the excellent talks and presentations that I've been listened to since yesterday. All of you come from different backgrounds with a common interest, of course, in technology, creation, art, and music. So today I'm going to present some of the ideas from my book that came up already, it's been a year ago at MIT Press, Art in the Age of Machine Learning, with a foreword by deep learning expert and Turing Prize winner Yoshua Bengio, and a focus on perspectives over embodiment and situatedness in artistic and musical creativity. But I'm going to expand it a little bit with some of my more recent work and also trying to focus a little bit more on the question of embodiment. So I'd like to invite you in this presentation to perhaps zoom out a little from some specific art forms and adopt a broader view of the field in order to see the many connections that I believe exist between, in this niche domain of machine learning enhanced creative works, between different kinds of art forms. So not only music, but also visual media arts, performance arts, and electronic literature. And so some of the, let's say, the three kind of core questions that I've been trying to address in this book, and in my current work too, I'm still kind of trying to find perhaps some answers to these questions. So the first one is more of an aesthetic question. What new forms of aesthetic experience do machine learning methods enable when they're utilized outside of their intended context and are instead carried over into artistic works? The other question is more about context and situatedness. In what historical, social, and cultural contexts in art, science, and engineering are these practices and works embedded? And finally, the core kind of question I'm after is about the practice. What characterizes this practice of using machine learning to make art and music? So things are moving extremely fast. In the book, I'm not even talking about prompt-based image generation. Can you believe this? I mean, it's just been a year, and this seems to be what's taken all over the world now. And when we talk about AI art today, This is kind of more like what we have in mind, right? This is, I don't know if you know this example, this was the winner of it's one thing that made the news. So Jason Allen is this game designer from Ohio, and he applied to a competition in the US, a state competition, and won the first prize in the digital image generation, digital image manipulation photographs or something like that category. And he had used Midjourney, which is a prompt-based artwork and technology. And so basically, it's just like inputted a few sentences and to get this image generated. And when the judges found out about it, I mean, he didn't lie. He said that it was made with Midjourney. Some people would say, you know, it's made with Photoshop or it's made with Illustrator. So he said it's made with Midjourney. But I guess the judges didn't know what Midjourney was, and some of the other competitors were angry. Everybody was angry. But he said, you know, I did spend a lot of time tweaking these prompts. And by a lot of time, I mean, he meant like a few weeks. So I don't know if to much extent it counts. But anyway, I mean, it's all very interesting and very cool. I mean, like I've also been using these prompt-based tools, and I'm certainly not against them. They allow anyone that, like, I don't know how to draw, and I can generate some really cool images, and I think it's opening definitely a new field of expression. But the problem I have is that it's kind of like what people think about when they think about AI and art, and to me this represents about like, what, 1% of what is possible, maybe less. So that's something that has changed since the publication of the book, is how the technology has changed and how the field of AI art has been transformed and reappropriated by the industry and by quote-unquote popular culture. And I had sort of hinted at these transformations in the book, and the book was actually kind of a response to the way things were already changing. But a year from now, it seems that it's really been taken over and hiding all this super interesting and super complex and super rich history and approaches that now kind of lie under the surface. So part of my objective with this book was to preserve that history of the emergence of the field since the mid-2010s as it was happening, and to bring sort of an inside-out perspective looking at these broader historical, aesthetic, and practice-oriented considerations. So let's begin at the beginning with some kind of human-machine collaboration. I'll read you a few lines from the introduction while also playing an excerpt from the piece I'm talking about, which is a really fascinating work by artist and instrument maker Nicholas Baginski, who in the early 90s created a groundbreaking robotic work with the band The Three Sirens. So I'll just play this for you and just try to adjust the... Aglapheme becomes one with the electric guitar. Her 6 artificial brains just got reset, her floating point synapses sprayed with fresh Gaussian noise, leaving her clueless face to her body environment. An impish, childlike spirit, ready to enact her own world, to explore and exploit the most intimate connections between inputs and outputs, to become and make become. The air is charged with static. The robotic siren hesitantly plugs the E string as she moves the slide in a downwards fashion, producing a shrieking, distorted sound. Thus begins a long and monotonic solo as Aglapheme obsessively plays the E note over and over and over. Nicholas Baginski is standing in front of her, mesmerized. The robot never behaved this way before. There must be a bug somewhere in the source code, a glitch in one of the rules governing her behavior. Maybe one of the pieces of hardware, like the pickup or the effects pedal, is not functioning properly. Yet, Baginski listens, enthralled by the strangeness of Aglafim's performance, as his own brain tries to make sense of the robot's neurotic behavior. 20 minutes pass that feel like 20 hours. The vibrations of the E string feed through the guitar pickup and then to a set of distortion devices. The filtered sound waves are converted into a frequency spectrum that is fed back into the robot's 6 artificial neural networks. Each net emits a digital signal competing for attention. And for the first time, since her synapses have been reset, Aglafim's A net screams louder than the E net, and the guitar bot nonchalantly pinches the corresponding string as if emerging from her torpor. During the rest of Berlin's second Electronic Art Syndrome Festival, a 3-day, 24-hour event near Alexanderplatz, the robot began producing more complex sonic improvisations, self-organizing around the physical qualities of the sound spectrum, developing a style of her own. For the next 2 decades, Aglafim would practice, rehearse, and perform, constantly adapting to the different sound environments to which she was exposed. Over these years, other robotic music players joined with her to form a jazz improvisation band called the Three Sirens. All music was played live, without any score, the result of the robot's self-adapting interactions that came by jamming together in rehearsals and shows. The Three Sirens constitutes an early example of a growing field of practice within contemporary digital art that engages with a form of AI, which you all know about, machine learning, which proposes, of course, a way to endow machines with intelligence, not by programming them directly with logic rules, but rather by allowing them to program themselves by learning from their experience. And almost left for dead by the end of the 1990s, this approach has gained impressive impetus since the mid-2000s, thanks to critical breakthroughs in fundamental research that triggered an unprecedented interest by the commercial sector and more recently in artistic circles, giving rise to a loosely defined artistic movement intimately related to previous computational artistic practices such as cybernetics art, artificial life art, and evolutionary art that I call machine learning art. So, the core argument I'd like to make to bring some kind of an alternative perspective over this very rich set of practices is that to understand machine learning art and machine learning music, you have to look at what I call the materiality of machine learning systems and how they differ from traditional computing. So, I think a lot of you, if not all of you, are already aware of how machine learning systems work, but kind of to find a way to boil it down to the core components, this is a bit what it looks like schematically. And so essentially you have 3 different components, 3 different parts. And this is very specific. This is very different from other kinds of generative programming-based practices, right? Because machine learning involves this model, which is kind of the program that is being trained using data by a training process. And so my point is that each of these different components can be, is first of all, as artists or musicians or composers, you can play on these 3 levels individually or all at the same time. You can also play, of course, with the evaluation function, which is part of the training process. And they each also involve a set of, or suggest a set of specific issues and considerations when working with machine learning systems for art making or music making. So the book is actually separated in 3 parts, each corresponding to these 3 elements. And I'll go through them in this talk as well, beginning with the model. So the models are what is actually being trained. It's what remains, and what typically, in most applications, that's the goal. I'll talk later about some other strategies where the model is not the final goal, but most of the time, you know, the goal is to use the data in the training process to train a perfect model, and then you could throw away the data, you could throw away the training process, and keep the model and use it. So the first point I want to make is that although when we talk about artificial intelligence, we tend to conflate, or when you hear or when you read the word, the expression artificial intelligence in the media or in papers, publications, or whatever, be careful, because it can mean different things for different people. And most of the time when you read AI or artificial intelligence nowadays, what it means is deep learning. So basically that's the definition of AI. It's not new, because in the 1950s, AI was chess playing. In the 1990s, it was maybe search algorithms. So it's like, this definition of AI is not inaccurate. It's just that you have to be aware that this is a definition that is not the only accepted definition, which means AI is the latest thing that we have that we think is intelligent. But 2 weeks after, somebody will criticize it, and then you'll have something better. So I like to call it the definition of AI as being like AI as a moving target, or AI as just the new computer science. The old AI is called computer science, and the spearhead of computer science is called AI. I prefer the definition, this is the one I add up in the book, of artificial intelligence as being this very broad and historic field that brings people together into trying to endow machines with intelligence or human-like properties. And if you think about it this way, then you can find that there's different kinds of models that you can use, not just deep learning, but also parametric systems for genetic algorithms, shallow learning, or even, there's not machine learning, but if you look at the work of Howard Cohen, for example, you can also think about parametric systems that are coded, that are not really trainable, or I think Howard Cohen, by the end of the last versions, had some kind of training in them. But anyway, these different kinds of models, whether you're using SVMs or market chains or whatever, they come with a set of specific practices, and they also suggest different kinds, they support different kinds of experiences too, and they also suggest different kinds of conceptual or imaginaries that are attached to them. You can think about how the evolutionary art movement starting in the 1980s that deployed in the 1990s was a lot about ecosystems and life, whereas like deep learning nowadays it's much more about a pictorial expression and mimicking, like thinking about the human brain and trying to collaborate with humans, so they just like have different kinds of imaginaries attached to them. So that's my first comment about model. But my second comment, which is more important perhaps, is that something that all machine learning models share together, that perhaps makes them different from the traditional coding or good old-fashioned AI, is that somehow they behave or act beyond human understanding. And what you see here is an example. So I can only think actually through examples. So I really like this example to kind of explain my thought process here. This is an experiment that was made in the mid-1990s by Adrian Thompson, who was researching, so he was using evolution, he was trying to use evolutionary computing to train circuits. So he made this experiment where they used FGPAs, so they're basically a platform that allows you to generate circuits. They're actual circuits. But what he did is that, so he tried to create a circuit that would take an input, a sound input, a frequency of either 10 kilohertz or 1 kilohertz. And in output, it would say whether it's 1 kilohertz or 10 kilohertz. And instead of trying to find the rules to do that, he just generated randomly a sample population of X number of circuits, sent the noise in, checked their performance, applied a fitness function to select the best candidates, then applied some kind of crossovers and mutation, a genetic algorithm process, and repeated this until they got the perfect circuit that optimally was performing on this task. You put 1 kHz, it outputs 1. You put 10 kHz, it outputs 0. And so when they got that, they applied a pruning process. So they removed every part of the circuit that was not connected to the rest or not contributed logically to the rest. And when they did that and they tested, it didn't work anymore. And the reason for that is that there were actually parts of the circuit that the circuit was using very small magnetic variations that could not really be explained rationally, but they were important in the recognition process. So I think to me it's a good example to show how modals are much closer to a form of bodies in a way. They have properties that are not logical properties. They cannot really be explained symbolic-wise. Because of that, and this brings us back to the art world, because of that I argue that they can only be known phenomenologically. So if I think about my experience working as an artist, for example, making robots, so I do a lot of projects where I do robotic installations. So before I was using machine learning, people would ask me, how does it work? And then I'd have to explain it to them, and it would be, yeah, when the robot sees this, it behaves in that way. When it sees that, it behaves in another way. And today, when people ask me how my artworks work, I just can tell them that I don't know how they work and that they need to spend time with them because I can't really explain it. So this is, you see here, the disconnected circuit and the parts that are grayed out are the parts that Adrian and his team had to re-add to the circuit. They weren't necessary as part of the computation operated by the system. I mean, can we even call it a computation? More like the kind of operations. So I'll show you one example actually from my own practice. If I can find, that's not it. It's not it. That's the one. So this is a piece I made a few years ago in collaboration with Istvan Kantor, Monty Kensen Amen, who is a very famous Canadian artist. You can look him up. He was active since the 1970s, and he started an avant-garde movement inspired by Dada and Surrealists and Pataphysics, but also by the punk movement and mail art. And part of this movement generated a lot of literature around this concept of neoism. It's kind of a nonsensical, very absurd kind of poetry that deals a lot with, it sounds a lot like propaganda for this for neoism, but it doesn't really know what, or addresses ever what neoism really is. And that's kind of like the pun to it's kind of a funny set of, but there's been whole books written about neoism. So we found all the texts on the internet we could, written by neoists. And they don't have really any author either, because it's very confusing. People would play pranks, so they would make fake names and to write about neoism. And what we did is that we trained a machine learning, we trained a neural network, recurrent, I mean, it was a LSTM. So we trained a LSTM on this text and then created this generator. But we wanted, so one of the principles of the movement is based on the idea that you can participate, you can destroy and rebuild, and that art is this constant performance of reappropriation and destruction. So I mean, like, the neoists would do performances where when they publish a book, they would burn the book, or Istvan Kantor got very famous with this performances where he would throw his blood on a Picasso and like yell big text on neoism and get thrown away of the museum yelling. So there's a kind of mixing these performances, this kind of reappropriation of culture. And so we kind of decided to re-embody that in the machine and to allow people to connect and disconnect the actual connections in the neural net in real time. And it really generates these weird, I mean, unexplainable, it's a kind of noise. So it's not really, and as you unplug the cables, to me it feels a bit like somebody who would slowly become, dement, go into dementia, and then come back as you plug the cables in. But what's even more fascinating to me is that when you look at this screen, your brain actually starts, even if it's completely scrambled, your brain makes some kind of sense of it. So you read something through these nonsensical words. So, so it was also very efficient to us as part of this movement is also about brainwashing people. So it's definitely a brainwashing machine. So just to show how just to get back to this, what I was saying earlier, about the fact that to me, these one thing that's very interesting with these models is that, here, for example, they have this, first of all, they do correspond to some kind of a brain, and that's kind of part of the play, but also there's no way to understand it really rationally because it's not a rational system. It's not like one cable corresponds to one letter or this cable changes the color in a certain way. You really have to explore it to understand it. So if we look at the other side, so just that kind of goes around with the models. Now, on the side of data, which is the basic nutrient that is digested by machine learning systems, the deep learning revolution has allowed for something very useful as compared to previous versions of previous approaches to machine learning, which is, of course, a possibility to use very flexibly data to train increasingly complex systems. And this has allowed artists with perhaps lower understanding of coding, for example, to create art with machine learning by working on the data side. And I'll pass a lot of examples to kind of focus on what is called interactive machine learning, which I think has been one of the first few very interesting developments in this. It actually, I'll just go to two case studies that both were they were kind of early adopters of these approaches in the music performance world, working with Rebecca Febrink's The Wekinator, which probably some of you know. So it's a tool that allows you to perform. So you can connect it with OSC, with sensors, And so you can perform, as you perform, you generate data, and you can train things in real time. So that's kind of the idea, that there's less of a separation between generating a big data set and then training it and then trying, and then so it really brings the creation of the connections between inputs and outputs, so the mapping in a more, almost in a performative way. So this is why Rebecca Fiebring, the author of the software, calls it a meta-instrument, because it's like an instrument that allows you to create an instrument. And one of the things that the research that she's done, in particular with Laetitia Sonami, who used her software for about 9 years, I think, is that it facilitated the kind of end-to-end mappings that are, when you use kind of traditional platforms like Dataflow, as I've been shown to, people have been shown to not explore so much these end-to-end mappings because they're less easy to figure out. So in general, people tend to do, map this sensor to a particular parameter and this other sensor to another parameter. Whereas with this, it becomes a bit more, it allows people to become a bit more fuzzy and a bit more, what I argue is that they develop some kind of more phenomenological, embodied, interactive relationship with the tool. So composer and performer Laetitia Sonami has designed an instrument called the Spring Spire using that approach. And it consists of 3 springs attached to audio pickups that are anchored to a metallic wheel. And the raw signals that she generates as she touches the springs are converted into different kinds of features using digital processing filters that are then sent as inputs to some shallow artificial neural networks that each produce a single output value. So these signals produced by the neural nets, they control different parameters of digital synthesizers that generate sound in real time. The composition rests on Sonami carefully and patiently training the different neural networks models. So this is where I think there's something quite interesting, is that like to compose with the instrument, you have to perform with it. So you perform the training process, in other words, to then be able to perform with the tool later on. And by playing with the width and the variability of the data through her own gestures, she's able to indirectly affect the unpredictability of the system. So in her own words, she says, if I feed the system training examples whose sound encompass wide changes based on how I touch the springs, trained model would move through all these points in unpredictable ways as the springs settle to a resting place. If I give it training examples with narrower changes, the sound will just oscillate slightly as I move the springs. I can thus easily scale the instrument between predictable and unpredictable results by changing how I train it. She's described her experience of working with machine learning as open-ended and flexible, which rewarded a more explorative approach than a goal-oriented one. And another example that follows also a similar approach, but with a kind of a different, more performative and so not only musical based, but kind of audiovisual performance, comes from Susan Kite, who is a Aboriginal Oglaga Lakota performance artist, visual artist, and composer. And she started using the Wikinator as part of her performative inquiries into contemporary Lakota mythologies and epistemologies. Her interest in machine learning emerged from a will to reach, as a performer, a dissociative state of perception on stage. Kite's performative exploration of these in-betweens through the relationship she establishes with machine learning systems coincides with the Lakota concept of wahan, which is an incomprehensible, mysterious, non-human instrumental power or energy, often glossed as medicine, which in Lakota culture forms the basis of relationship between humans and non-humans. So through her work, Kite is interested in establishing relationships with non-human agents, such as AI entities that respect indigenous ethics, which from a Lakota perspective means knowing that non-humans have spirits that do not come from us or our imaginings, but from elsewhere, from a place we cannot understand, a great mystery, wahan, that which cannot be understood. So this is an excerpt from one of the articles she published on the subject with other Aboriginal scholars called Making Kin with the Machines. I really recommend that reading. Another thing I argued in the book that is related to the subject of this workshop is that machine learning would open the way to a new era of algorithmic remixes allowed through machine learning model. And this is, of course, happening right now. And what I mean by the remix culture, the kind of the new parameters or expansion of that remix culture is that the remix culture was built on the, well, it started through the automation of reproducibility of media. So you can think about the Dadaist collage, for example, or then starting in, I think, the 1970s, where people started to sample music and make music by building, so by collaging different samples. And my argument is that when you have systems that can, instead of just collaging things together, can be remixed in a way that is very different, because you can remix a voice, so you can sing, or perform by using somebody else's voice, for example. Then it creates something else. And I think, of course, there's implications in terms of copyright, but what I'm most interested in are the implications in terms of possibilities. But in terms of an expansion of this remix culture, the Creative Commons. And last year, actually, it was, I think, in January or February last year, Holly Herndon, who has done a lot of early work too with these systems, did this interesting move of releasing her own voice in the public domain through a Creative Commons license. So, so that you can actually resample, use her voice as part of your own piece, and that she's okay with it under certain kinds of parameters. So let's now move towards the last part of this kind of material organization of machine learning systems by looking at the learning process itself and its implication for artistic and musical creation. So machine learning systems are good at optimizing stuff, right? So it would be tempting then to frame artistic creation as a problem to be solved by machine learning. In other words, finding an objective function that would measure creativity or aesthetic value. And this is what a number of people working in the field of computational creativity attempt to do. You know, they're trying to find algorithms that and implement an objective function that would kind of match this tension, let's say, on one side between generating some new stuff, so novelty, and also generating something that is interesting, not complete chaos. And you probably have heard maybe of that publication from a group at Rutgers by Ahmed El-Yamal and his team, Creative Adversarial Networks. So that was back in 2017. But I like to cite that study because it's one of the first that really kind of made a breakthrough in that field, and that came with a really interesting user study too. So, they basically they created this this GAN that was trained on paintings, and they then were able to generate some new images. And then what they did is that they took a random sample of people, and the people were shown images. Some images were of actual paintings by humans, and some images were from their system. And then they asked them a bunch of questions, like, oh, is this a nice painting? Is this, what age? What's the year it was made? And of course, they asked the question, was it made by a human or a machine? And so So when they would give images from abstract expressionists like American abstract expressionism, which is very, very common. People have seen a lot of these images. Then in 85% of the case, people would say, yes, this is made by a human, and they were right. And then when they were showing images from their algorithm, 53% of people wrongly thought they were made by humans. So, you know, pretty good. Like, they kind of passed the Turing test. They were able to fool people. But to me, the most interesting result is that when the images were images from painting from the latest art fair at Art Basel in 2016, which is supposed to be the creme de la creme, the top of the line of this is where the best painters are showing their work. Only 41% of people said that they were made by humans. So I don't know what it means. Does it mean that contemporary art is made by machines, or that? I think it tells a lot about, you know, what that the value of art, or that the evaluation of art, what is, and even what is human, what is non-human, is very subjective. So this whole approach of trying to find the objective function, or a single objective function, to train a system to generate art, to me is kind of doomed to fail, or at least it needs to be taken with a lot of nuance. And this is what actually, way before this happened, in the mid-1990s, the artist Qamar and Melamed actually made a project that I think is really an early take on this situation. What they did is that they ran a survey. They asked people, I think 1,000 people, questions about what they like to see in a painting. Do you like to see a river? Do you like to see a tree? Do you like to see what kind of colors? Green, yellow, blue. What are the colors you like to see? So they asked like 100 different kinds of questions. And based on the responses, they made this painting. They actually made the most wanted and the least wanted. So you can actually look online at their work. It's really fascinating. And they also have it, because later on they ran surveys in different countries. So you'll see if you go that the Dutch have really peculiar tastes in painting compared to the rest of the world. But anyway, this is America's most wanted painting. And the point of Qamar and Melamed in doing this was to say, on one side, because you look at this painting, you're like, this is not what we think about when we think about contemporary art, right? This looks like a very kind of ordinary painting. There's nothing really new or revolutionary about it. But at the same time, they were also saying, well, maybe we got it wrong. Maybe, you know, maybe this is actually what people like. So why wouldn't we call it art? So my response to this is, like, as you see, is that there's not really any response. But the point is, of course, that it's not as simple as it looks. So if you can't use optimization directly, then what do you do? So there's a bunch of strategies that came, that have been in use, and I'm going to talk mostly about this one, which is about, I called it curbing the training curve, where some artists have been working on exploiting the learning process itself as a source of engagement or development, deployment of behaviors or form. Carl Sims' Galapagos, mid-1990s, with evolutionary systems, where the public, he actually embraced this idea that the public would influence the training process. So people could select the organisms that they preferred, and it generated the next population. But it was constantly flowing, because as new people were coming into the exhibition space, there was not really any pure end objective, because everybody has different preferences. And on the right here, you see this piece. This is a robotic piece by Petra Remenbuk and Rob Saunders, who made this installation with robots that are hiding behind, so they build a fake wall inside the gallery space, and there's robots that are attached to these walls inside on rails. And the robots are driven by by curiosity. So they implement some kind of a function where the robots are basically rewarded if they discover something that they couldn't predict really well. If they do something and it does exactly like they predicted, they're going to get bored and do something else. So over time, these robots are equipped with drills, and they start drilling through the wall and looking at the public. So there's kind of then this coupling going on because of curiosity, right? Because the public is also curious. It kind of inverts the perspective of when you usually go to see art in the gallery space, where suddenly you are the one being observed. So that's another example of kind of play on this objective function, play on this training to generate some kind of evolving behavior. And so one of the core arguments I've deployed in this book that I'm continually interested in is to try to find ways to refine what Simon Penny, who's a sculptor and scholar working in California, has been working since the 1990s with robotic systems, what he has coined the aesthetics of behavior. So Penny was working in robotics and was a contemporary of people like Bill Verne, Louis-Philippe Demers, and Ken Rinaldo, who were building these robotic artificial life systems. And he said, well, when you go and look at a robot that behaves in a certain way in the space, it's not visual arts anymore, it's not sound art, there's something else that is going on. What is given to see is really a behavior. It's like looking at the behavior as a source of aesthetic. And this opens up a new kind of aesthetic domain, aesthetic field. So, and when you think about the behavior, I kind of like I kind of like starting with this definition from Gordon Pask. Who said that a behavior is an unchanging form of events due to some kind of activity within an assembly, or I call it an agent or a system. I mean, you can think about the robot, but you could also think about I like to think about an animal, for example. So if you think about the behavior of a cat as it's hunting, right? The cat hunts. It hunts one day, it hunts the next day. Every time it hunts, it's not like a video. It's not hunting exactly the same way, pixel by pixel, right? Atom by atom. It's never in the same place. It's never doing exactly the same thing. Yet, you can look at the cat and say, right now it's hunting. So that's what we call the behavior. And if you think about it that way, then you can think about generating behaviors with, of course, with robotic and computational system as one way to generate emotions, to express situations, and to create some kind of projection to, or evocation in the viewer. Now, the question I have is that if you have systems that learn or that evolve, what happens when these forms of event change through time? So, so this led me to imagine that maybe we could kind of distinguish between different kinds of behaviors. The first order behaviors, which are, the cat hunting, or you look at a robot and after a while you figure out that the robot is behaving in a certain way. I don't know, it goes in circles, and when it approaches you, you go towards it, it goes back. So after a while you might, get what's going on. And these are the kinds of behaviors you can generate with coding, with just like traditional, good old-fashioned AI. But with machine learning or adaptive systems, or even with evolutionary system, I'm arguing that we have something different. So you can think about, like, again, back to the cat, you think about the kitten that's learning to hunt. So it's hunting, but the way it's hunting will change over time. Or you can think about the cat as a kitten, and then midlife, and then when it gets old. You know, its behavior will change over time as time passes, and as like either the conditions or the learning transform the behavior. So this kind of leads me to try to think about behaviors as things that can fluctuate, that can go from phases where they they go through some kind of morphogenesis. They start from pure random to stabilized to a form of morphostasis, and then they can metamorphose into something else. And this vocabulary was actually inspired by the work of Yannis Xenakis when he was describing formalized music, looking at different kinds of stochastic systems. I'm currently exploring those ideas in the work in progress, which I'm just going to show you an excerpt here. So this is with my collaborator Rosalie Dumont-Gagné. We're working on this robot installation, and we set ourselves one big restriction, is that we said we cannot control directly the robots. They are learning, so we use reinforcement learning, and they have to learn in real time. And we need to create some kinds of, and what we want to see is what kind of behaviors can emerge through this. So in the first example that you saw, we can generate I'll get back to it later, but we can generate different kinds of behaviors. So in this case, I think you'll kind of guess as it goes what is the reward function. But the thing is that every time it might behave differently, and very often, well, not always, but it depends on what it has to learn, but it fails also. Sometimes there's moments where they can't do it within reasonable time. So, but sometimes, you know, they manage to do what we trained them to do. I'll just get back to the other. So this was a reward function based on proximity. And here, in this case, it's kind of an individual behavior where we reward them for moving their motors, but we punish them if they move in this space. So they have to find a strategy to kind of tilt, and it creates this kind of dancing behavior that we find was quite interesting. But you see that it's different also. It will be conditioned also by the shape of the robots. So we'll have 3 robots in the end, and they'll have different kinds of skins on them, which makes them either heavier or more bulky or with more convexities. And that also influences their behaviors. So we can talk about this also during the period question. So now we're reaching the last part of my presentation, where I'm going to try to kind of like open up to some questions that are constantly in my mind right now. So with all of this, what's going on when you create with these forms? Whether it's with any kind of embodied system, whether it's a robot that makes music, whether it's like Susan Kite has this, she uses this braided, traditional braid with sensors on it. So where does the creation happen? Is it in the brain? Is it in my brain, in my hands? Is it in when I collaborate with someone? Where is it happening? Is it the robot that creates? How does it happen? Who or what creates? And then what is creativity, and what are art and music? And how maybe these technologies can inform us as to how they're being transformed, how these notions are being transformed. So if you look at the literature on creativity, computational creativity, a lot of people have been basing their work on Margaret Bowden's, I would say, revolutionary take on creativity, where she says essentially creativity is novelty and value. So it's something that if I create something, it for it to be creative, it needs both. So if I have gold, it has value, but it's not creative, right? If I just make some random noise that nobody cares about, it's novel. Nobody has made that noise before, but it's not necessarily creative. So you kind of need both. So, and she also said, well, novelty is easy for computer systems. The value aspect is probably the hardest to find. And I think a lot of people are struggling with that. But the problem I have with that is that it really focuses on the properties of a system. Is this system creative or not? Whereas, so I can't pronounce that, Csikszentmihalyi, I can't pronounce the name, sorry. Kind of has a different take on creativity and says, well, actually, it's maybe what's more interesting is not so much whether an agent is being creative, but that the creativity is more kind of a process that's distributed through a set of relationships. And Oliver Bone published a book 2 years ago that's also excellent, where he makes the argument, and I really agree with him, is that he said maybe we have to refine a little bit this idea of Margaret Bowden and see how art is also contextualized. Art and music are always responding to some kind of situation, social, cultural, economic, political, and embodied as well. So Bone says we should maybe rephrase it, maybe we should say creativity is the situated production of novelty. So what matters for Bone is not whether creativity comes from a particular agent, but rather what roles are played by the different agents involved in the creative process and the relationships they establish with each other. So after Pickering, I'm just reusing this concept of dense of agencies to reframe creation as a non-human-centric, network-based set of relationships and roles between different kinds of actants and agents, artist, artwork, agent, the audience, the materials also, like everything that is in this network is important. It's embodied and situated in a certain context, historical, cultural, social, and material. And we have to think about all of this to really understand what is going on with the creation. So, so as a first step towards kind of understanding that, I started to look at how artists were, in their own words, considering their work with, or their relationships with the machines. So, and I mean, there's a lot of them. Well, I'll just name a few. One that is very common, but it's commonly said, but it's not so common coming from artists. But Sogwen Sheng uses that word of collaboration. So, so the idea that you are building a system, and then this system becomes kind of an equal partner in the creative process, and there's really this conversation of going back and forth. She uses it as part of performances with a robot trained on her own paintings, which she then starts to create with her. Another way that artists commonly describe their relationship with machine learning is as it changes the role of the artist from one that is closer to a kind of craft, or William Latham called that gardening. So he said, you know, you generate all these possibilities, but you have to go and, you know, cut the plants and put do the right kinds of mixes to keep the garden in order, but let the garden, you know, reach its most interesting state, but through this attention that you're giving it. And the idea of crafting was also brought yesterday, I think, during Sarah's presentation. So, so really creating data sets as a kind of craft that then you can use to generate models. I really like this metaphor that was brought by Memo Acton, who said, you know, that to him it felt like more like taming a wild animal, so taming a wild horse. So when you tame a wild horse, has anyone here tamed a wild horse, by the way? It's usually the case that no. I asked that question once last year. I was interviewed by a guy running a show, and he said, actually, yes. He said, I was born on a farm in Texas, and I did tame wild horses. We had a conversation about that. But essentially, when you can still imagine how it would feel like to tame a wild horse, where you probably kind of have to let the animal go its own way, but, you know, kind of use what you have, take the reins in one direction and maybe push with your feet, and slowly, you know, through trial and error, you get kind of in tune with one another and you start to develop some kind of a common language. So Acton says, well, are we collaborating? I don't think so. I don't think we're collaborating, but we have, in order for me to go where I want to go, there has to be this process of trial and error and mutual recognition. And from this, I started thinking, and I realized that in French, actually, the word taming has two translations. There's one translation which is closer to that one, that from EmAI, which is called, in French, it's called dompter, which is more about really trying to control a wild animal. So you can imagine someone in a circus with a whip, you know, and like wild beasts. So that's one sense of the word taming. But the other sense in French is called apprivoiser, and it's a very interesting word. And to me, this is really how much closer to what it feels like to work with machine learning. So there's this this story in the book. Maybe some of you have read it. I think it's been translated in many languages. Called "The Little Prince" by Antoine de Saint-Exupéry. And I don't know who has read this book or is aware of that book. Okay, so the little prince goes from planet to planet, right? And he meets all kinds of characters. And one of the characters is the fox. So he meets the fox, and the fox tells him, he says, "Please tame me, s'il te plaît, apprivoise-moi." So he asks him to tame him. But the word in French is not tame, it's apprivoiser, it's not dompter, it's apprivoiser. It's very, very different meaning. And he says, so I'll read the excerpt in English. He says, to me, so he's talking to the prince, he says, "To me you are still nothing more than a little boy who is just like 100,000 other little boys, and I have no need of you. And you on your part have no need of me. To you I am nothing more than a fox, like 100,000 other foxes. But if you tame me, si tu m'apprivoises, then we shall need each other. To me you will be unique in all the world. To you I shall be unique in all the world." So this process, what he's saying is that if there is this process, and the fox, what's interesting also is that it's not a collaboration. The fox cannot tame the little boy. He's a fox. So it's the human that has to do that work. But it's an activity. It's a process, and the meaning of the word that brings in a lot of. It's very charged. So first of all, it has to come from a position of empathy. That's part of what it means. It's something that cannot be forced, can only be reached through patience. It's iterative, and it's about building trust. It's about making space for the other. There's also some kind of almost seductive process, some kind of a dance, a mutual creation of a relationship of these two different entities that come from very different worlds. And it's really about getting to know the other. So to me, that's the closest metaphor I can have in my own work, but I'm sure everybody here has maybe some other ideas that they'd like to share later. So I'd like to finish by circling back to the question at the core of this workshop: how can we make music with AI in the future? And as a summary and a tentative response, maybe a few provocative thoughts. So the first one is that, like I said earlier, art and music are contextual. We're not going anywhere. There's not like, we're not gonna go and make better and better and better art and music thanks to AI, or like there's no clear path to where we're going. We're evolving in a very complex system, and there's no objective function for that. Another thought is that nature is, I was like, nature is not technology, but maybe it is, I don't know, but it's more of an open or nuanced perspective, but I think that basically this dichotomy needs to be at least questioned. Creativity is a property of, no, it's not a property, it's a dance of agents, so it's more an activity and it's more about relationships. And finally, and I'll end with that with actually some quotes coming from an article I've been working on with my students, Victor Drouin-Tramp and Ola Siebert, about this Three Sirens work and the imaginaries of it suggests in terms of the nostalgia of the future for artificial intelligence. The tensions between human authorship and machine autonomy are articulated in the imaginary and nostalgia surrounding the dream of artificial creativity. Baginski's The Three Sirens invokes the story of the mythological sirens, which provides an appealing metaphor that broadly applies to machine learning, art, and music. The sirens' enthralling chants force us into a liminal state of being between curiosity and fear, where we are faced with a choice. Either plug our ears and refuse the possibility that the robots or the agents or whatever are genuinely creative. We can either do that or accept their chants as real music at the risk of losing human exceptionalism as the only true creative species. Or we could try to hear the music while binding ourselves to our human-centric worldview, like Odysseus made by binding himself to the mast, so he could hear the sirens chant. Lurking at the frontier of human and machine, of musician and instrument, of artist and artwork, the sirens make us consider such notions as musical growth, creativity, virtuosity, and improvisation in relation to both human and robotic musicians. These reflections hint at nostalgia for the future of music, where our speculations are tainted with certain nostalgic feelings about sounds and musicians we already know. We then may be asking ourselves what new musical forms could emerge beyond the human realm, moving from music as it is to music as it could be. Tak, thank you.
Thanks a lot. That was a fantastic lecture. We do have time for some questions. Anyone out there? Yeah, there's one there already.
Thank you, Sofiane. Really nice talk, very inspiring. I do have a couple questions to start with. The one about the fact that deep learning is actually taking over, in a way, kind of shadowing all the creative and historical type of work in AI that have existed and that are still existing nowadays. Can you maybe elaborate on the fact that that's really related to an industrial kind of discourse, kind of like what Facebook is doing with Meta, almost convincing us that it's inventing something that's already been there.
Mm-hmm.
And I think somehow, you know, like Google and other GAFAs are really kind of pushing towards that kind of overshadowing of the diversity of what can exist in AI. And then my second question, I'm really interested in knowing your perspective on whether really AI does create a new aesthetics, or does it does it not just kind of reproduces existing currents, like these collages or remixing, or even what we see with the Ganism, you know, that can somehow refer to other currents that existed in painting. So what is the novelty? It's kind of broad question, but I'm interested in your perspective.
Thanks. Maybe one answer I can attempt for the first question is that, well, first of all, the fact that, we're seems to be focused on certain kinds of art forms and not others. I think, this is just something that is kind of, I want to nuance that first and foremost. Here I'm talking about what you see in the media. And of course, like within creative communities, I think a lot of people are aware that, there's more to it than that. This being said, I do think that, and there's clear evidence that IT companies are pushing for certain kinds of aesthetics and have been pushing actually since a while, since I would say probably since the early 2010s, on certain kinds of aesthetics. I mean, mainly visual, for example. Whereas, which is kind of surprising in a way because there's so much work that's been done in music. But, we live in this world of the visual and the internet and everything. I think this has to do with it. And it also has to do with the fact that these companies make most of their profit in advertisement. So they're really in this world of images, and this is what they're funding. Now, I think that the reason why they are pushing for certain kinds of narratives around artificial creativity can be explained, similarly to how different forms of philanthropy in the past have also been exercised as a way to avoid support public acceptance of certain kinds of technologies in this case, but of capitalism more broadly. So in other words, it's just cheaper for Google to have a Google art platform. I mean, it costs nothing. It's nothing. Like, we're nothing in this industry. It's like, I was trying to, maybe this will be a comparison you guys will understand. The technologies that, I find it really funny because, when Google created Google Magenta, remember Douglas Eck was saying, "Oh, we're making the next electric guitar." I thought, well, this is interesting because, the electric guitar was, created by Fender, or or they were, I'm not sure which company, but I think it's Fender, what was one of the big early companies that, think about the Moog, think about, companies like Yamaha, who have really contributed to the instrumentations that have had an impact on music. Well, these companies sell instruments, right? Fenders, they're in the instrument business. Google is not in the instrument business. Google is in the advertisement business. So to me, it's a bit like if a car company was making instruments, I mean, maybe it's okay, but how would you feel about buying a guitar from Toyota or Dodge? I don't know. Maybe it's fine, but it's just the same kind of industrial complex that is providing these tools is actually making profit from advertisement. And what is advertisement? Advertisement is about transforming people's behaviors in order to sell them stuff they don't need. I'm sorry, but that's what it is. And the thing is that these companies, they know that they have that their technologies are problematic. And they know that that they could be regulated. They have been regulated here in Europe, but not so much in the US. And it's just cheaper for them to make sure that the image that's going to go with the article on AI is not the face of the Terminator, but a cool image from Deep Dream. So that's all I'm going to say about that. Maybe it provides an answer to your first question. And your second question was... Just can you remind me?
About reproducing existing aesthetics.
Oh, yeah, that's right. Yeah. Most certainly, because of everything I've said, that art and music they don't happen out of the void. They're part of a human culture and history. And of course, we're always building in reference to the past, to things around us. I think what AI does is, and I think it does it in many different ways, so I think it's hard to give an answer that would cover all grounds. But I'll focus just going back to this materiality. Like, to me, if you want to understand what's going on and how it is different, you have to look at how it impacts practice. And it impacts practice in a number of ways. First of all, it creates this. So it gives access to forms of generative computing tools and possibilities, but not in a direct way. You're not you're not tuning one parameter that's going to change the speed or the frequency, or you're changing a knob that's influencing something, but that something is autonomous to a certain extent. So, like, back to this analogy of the apprivoisement or the wild horse, whichever you prefer, you can't control it, but you can't control it, but you can still do something with it. And this autonomy is actually something interesting, something that you can look after. And I think maybe it then also brings us back to certain forms of more out-of-control artistic approaches, maybe more performative. There is this, and that's why I mean, like, if you look at PromBase, it's very directive. But I think, like, most of the interesting stuff is in this space that's opened up, where suddenly you can defer a lot of agency and control to something that's kind of outside of your own reach. And I think this is probably what's the most transformative, is that I guess, it's just a guess, that the transformation it can operate on society and on art is this kind of new ethos of letting go and accepting that we're part of a system, and that, we have to break from this notion of the romantic solo artist who's like, where all the control and all the decisions come from immanent source of creativity that's human-centric. At the same time, we are humans. We live in a human world, and, I think it's not possible to think about art as completely beyond that. Like, it would be something else if it was art made by robots. Maybe the AIs are already making art. We wouldn't know, because we'd find it really boring, probably. But I think that this is the question for the future of art. Is like, okay, well, how can we negotiate between this the fact that we live in this human-centric, we see through human bodies, through human eyes, yet we're just part of a larger system, and this is where the creation happens. It's not just it doesn't emanate from us. It emanates from our relationship with the world.
Other questions? Oh, I have one here.
Hey, Sofiane, thank you for the wonderful talk. I haven't had the chance to read your book yet, but now I think I'm going to push to get a copy. I have a question about, so you were giving this metaphor of the Little Prince as kind of your, maybe the most, the metaphor that you resonate the most with, the metaphor of the Little Prince taming the fox, or the dance between them in the act of taming. And you mentioned quite a few times in that metaphor the phenomenon of empathy. And for me, this is very dissonant because I have a hard time thinking about how to have empathy for inanimate human-made artifacts. And so I'm curious, where does this empathy come from for you? What is the seed of it, and what is the dynamic of this empathy like for you?
Yeah, thanks. Thanks for this. You're giving me a good opportunity to precise my reflections on this question. So when I talk about empathy, I have the same feeling as you. And what's funny is that I wouldn't have said that, I think, before, especially this latest project I worked on with the robots, where we spent hours just trying to, give some kinds of, like what we do is that we create some kinds of situations, so certain kinds of perceptions the robot has, certain kinds of actions it can make, and some kind of a reward function, and then we let it go, and then we see what happens. And often we have to run it several times because it doesn't always behave the same way. And then we make an adjustment. So as we go, we kind of have to, and the thing is that we very often are feeling what we live switches from expectation to, most of the times frustration, because it doesn't behave, well, it's like it doesn't do what we expect it to do, yet we are not sure exactly what we expect, so it's kind of a weird feeling. It's kind of a, now I think about it, it's kind of a problematic feeling if you think about, it's like asking your kids to behave in a certain way, but you won't give them the answers, but you're frustrated at them, so it's a bit like that. But when I talk about empathy, it's that as we look at them, when we have this frustration at first, then we go back and we're like, yeah, okay, but we don't live in the same world as these robots. They have to learn something as stupid as going close to one another. It sounds stupid because we look at it from an outside perspective. But the robots, when they start, they don't even know what they're doing. They don't even know the world they live in. We see them moving. They don't see themselves moving. They're just pushing buttons in the dark. So when I talk about empathy, it's not about feeling bad or feeling like some kind of emotional connection, personal connection to them necessarily, but it's more about empathy in the sense of putting yourself in the place of. So we constantly have to. So it's about this. It a bit comes from this outer minds problem in philosophy of mind, that the only kind of inner experience you have access to is your own, and there's no way you could even for other human beings, there's no way you can really know what it feels like to be somebody else. If I were to connect each of my brain cells to your brain cell, I would be the one experiencing the world through your brain, right? But I wouldn't be you. You see what I mean? So that's the other mind's problem, and it's the same thing, especially with animals or plants. It's just, you can only kind of make presumptions or try to predict, and this is where behaviors come handy. It's like you predict, you're like, oh, my dog is behaving a certain way, that must be because it's hungry or there's this or that. But but so you have to make these suppositions, and the difference with the dog or the animal is that we still have a bit of control over. I can control what the robot sees. I can control what kind of information it has. So I have a little bit of access to that, but it's never the same. And we have to kind of break down the fact that we see the world through our own perspective and try to reach the level of the robot. So it's in that sense that we're empathetic. So I hope it clarifies my thinking here.
Cool. Yeah, one more here.
Thank you for an interesting talk. Just following up on the same thing, and how I'm not sure I have a clear question, but I'm thinking of like and removing the human from the centrum, and how there's something weird about wanting to change your collaborator. If you're thinking about the robot.
Your what?
Your collaborator. If the robot is your collaborator, it's something a bit weird about wanting to reprogram them. If you think of it in the sense as you wouldn't do that with the human. So I'm guessing what I'm wondering is how you have you thought about, or like how do you change your perspectives or expectations or whatever in terms of like actually meeting it halfway?
Mm-hmm. No, that's very important, and that's another. I didn't talk about that, but that's another. It's also part of this concept in French of apprivoisement. So the word apprivoisement or apprivoiser is a verb, apprivoiser, can also be used. It can also apply to situations in French. So you can say, j'apprivoise mon nouveau job. I'm taming my new job. Or I'm taming the time. J'apprivoise le temps. I'm trying to take the time to take it as it goes. And so part of the concept actually implies mostly a change from your part. Because it's very different. There's another word, because somebody said that I was asking on the internet, is there a word for this in English? Somebody said, I think it's like domesticate. But I said, no, there's a word in French, it's called domestiquer. It's not the same thing yet. Because domesticate, it comes from, in Latin, I think, domicile, like it comes from the house. It means to bring into the house. So you take a wild animal and you're going to make it human, part of the human world. But when you apprivoise, you still, in the end, the fox is still a fox, there's this. In the story of the little, I could imagine that if there is this apprivoisement happening, the fox will still be living out. It still will be a wild animal in the end. It won't go into the house of the little prince. But every time the little prince will go outside, the fox will come and they'll spend time together. So they still live in their own world. And the main person who has to change is the person who is doing the taming, the apprivoisement. It can be mutual if it involves two humans or two entities. Sometimes you would say, so for example, it's common to say if you have a new special person in your life, you'll say maybe in the first times you'll say on s'apprivoise. We're trying to we take it slowly, right? So there's this process of seduction, but it always means there's not this intention of control. That's it too. Is that in taming there's an intention of control, which in apprivoiser there's not the intent. The first intention is one of curiosity, of getting to know, to make place to the thing, and then. Definitely, there is this you have to change yourself when you work. And I think this is, to me at least as an artist, this is one of the first things I learned as an artist, is that and this is something that's very different from science, is that if you have this option and you have to use it when you're an artist, You know, you make something, there's a glitch, there's a bug, there's a problem, but maybe you're like, oh, well, that's actually interesting, and I should explore it rather than trying to, you know, control everything. Because this is how the most interesting art to me is happening. It's exactly like I was saying. It's like it happens outside of myself. But yeah, it is part of the concept too. That's why I like this concept.
Cool. We're getting closer to the coffee break, but one more here.
Yeah, thank you. I wonder, what do you think about the role of curiosity in the agents? Like, you're always saying that, the agents don't have any insight or don't have any picture of what they are doing. But what if we kind of add some element of curiosity to the agents and they make them wonder about new patterns that make sense for them, not for us?
Yeah. Well, I talked about this piece from Petra and Rob Saunders, the robots behind the walls that are. So we've actually we actually have one of the behaviors with the robots that we like that is run by a curiosity reward function. So this is called, I don't know if some of you are aware of, but in reinforcement learning it's called intrinsic reward. The idea is that it actually was developed not for art, but really as a strategy for exploring the world in a more efficient way. So if you think about, let's say you're playing, I like this example because it's easy. You play a Super Mario Brother, Super Mario Bro, and then you have this little thing, the Mario that's going from left to right and you know, that needs to kill monsters and jump. And so if you try to train a reinforcement learning agent to play Super Mario, it's actually really hard because you know, you actually win when you reach the end and you have to jump and pick the flag, but you have not many information as to what to do in between. And then, so I'll pass, like there's many strategies to try to circumvent that, but they're not really good. But so the premise is, okay, well, what we're going to do is that, you know, we'll have the agent just play, just discover the world, and you know, it's a strategy that you find in nature. We all have been doing and if you think about kids, you know, kids are really curious. They spend hours just playing, throwing one thing in a certain way and looking at how it falls, and you know. So the idea of curiosity is that the agent will make an action in the environment, and then it's typically modeled with a second neural network that just tries to predict what's going to be the next state of the system if it makes a certain kind of action, and the more so it's like, oh, if I'm here and I jump, I think I will end up here, then it does it. If it ends up exactly there, it gets 0 reward. If it's completely off, it gets a lot of reward. So it's going to be tempted to do things that are that are surprising to it. But as it does them, it becomes better and better at predicting. So it's going to jump in the hole like 1,000 times. But at some point, it will get the principle of, okay, when I do this, I jump in the hole. And it's not because I lose point that I find it boring. It's just boring because I get it now. I understand that this is happening. So this is how artificial curiosity works. And it's a very interesting function. But the thing is, we've used it with our robot. And of course, it's very dependent on what kind of observations it has. If it has information about its acceleration or its position, it's going to yield a different result. I really like, personally, looking at these patterns, especially if I think that this is the curiosity pattern, because it's really strange. Like it definitely moves a lot, and it changes. It will go in certain situations. I think if you really stay for a long time, you appreciate that behavior. But at the same time, it can be frustrating because it's really unclear what is happening. So it's really you know, it's different from having a behavior where the robot is moving and suddenly it stops, and then it's like, okay, like something like we get what's with the curiosity. It's never fixated. It's really like this second order behavior where the behavior itself is constantly shifting. So in terms of like turning that into an artwork, I think we'll put some of it, but it can't be the whole thing because I think it's too almost too incomprehensible. And I think this really points to also the choices you have to make as an artist to try to also, we were talking earlier, somebody I remember mentioned something about, you know, what if AI would make their own art or something like, so we still live in a human world with humans looking at things, having certain kinds of expectations when they go to a gallery space. And so you kind of have to work within those limits and make things that make sense. So you have to bring meaning. Yeah, it has to make sense to the human, but by using the capabilities of creating some strange and surprising results coming from the machine as a way to push the boundaries of meaning. So.
Great. I think we are moving into the coffee break now, so we can continue with the discussion there. So thanks a lot again to you, Sofiane, and another big hand.
Thank you. Thank you.
Any messages from you, Tari, before we...
Yeah. Thank you, Sofiane. This break will be slightly longer than the previous one, so we're going to meet here at 3:30. And in the meantime, for those who are interested, they're going to be slightly smaller Ritmo tour because some of the labs are in use for experiments right now, but you will get to see some of them at least. So downstairs we're going to meet Kayla, who's our lab engineer, Ritmo's engineer, and then Porman, lab engineer. And yeah, she's going to show you some of our facilities. Thank you. We're gonna start in a minute. Okay.
Okay.
So I think the first. Okay, everyone, welcome back. It's good that you're still hanging there after a long day. So we have one more session, and the theme is mapping and control. And it's going to be chaired by Tejasvini Kelkar from University of Oslo and Universal Music, both the affiliations. Yeah, the stage is yours, and then after the session, I'm gonna give some more information about the rest of the day. For now, enjoy.
So am I starting? Oh, yeah. Okay. Let me start my. Can you enable screen share so that I can share my screen? Oh yeah, great. Yeah, thank you very much for the invitation. And so I'm presenting a short presentation about a research that I carried out together with Federico Visi, who can't be here today. My name is Nicola Hein. I'm professor of digital creation at the Musikhochschule in Lübeck in Germany. And I've been working a lot in the field of human-machine interaction. And this research project that you will see was presented at a conference that I organized back in June this year called Improvisation, Ecology, and Digital Technology. I came up with this research project thinking it would be very interesting to invite Federico as someone who has a different approach in working with digital agents to work together with saxophone player Simon Rose, whom I'm also playing with a lot, and dancer Ingo Reulicke. So the setting for this group here, you can see is me on guitar, Federico Visi playing a Mayo band and electronics, Simon Rose performing on the saxophone, and Ingo Reulicke, the dancer. And we were basically forming a sextet together with two artificial agents or virtual agents, one of them being trained on my guitar playing and the other one being trained on the saxophone playing of Simon Rose. So basically you have 4 human performers and 2 of them have a sort of virtual alter ego. In this case, now I'm using an MFCC and KNN analysis in order to generate a virtual version of myself that is very much working with the musical behavior and the musical sound that it learns from my playing, but that will totally go its own ways with that. And I've been very interested in sort of developing virtual agents which are trained on the musical vocabulary of actual human performers, while on the other hand, changing the behavior of this musical material. Federico, on the other hand, is using MLP and a Mayo band that is trained on the saxophone playing. It was 40 minutes of Simon Rose performing solo. And here is, on the one hand, being triggered by the dancer Ingo Reulicke, and on the other hand, by himself. I will play you, I think I need to redo the screen share and select audio. 1 second, I forgot this. I will play you 2 short excerpts of the 2 virtual agents so that you can get an idea of their sound. So the first one you hear is the virtual agent that is trained on my guitar playing, interacting with myself. The second one is the virtual agent programmed by Federico Visi, here controlled by a Mayo band and trained on the sound of Simon Rose. And so in the rehearsal process, we really worked on sort of working out different settings and finding different sort of subgroups within this text set in order to find different human-human and human-machine and machine-machine relationships. The performance in the end was 40 minutes, and I'm showing you like a 1 minute cover of different settings that occurred within this 40 minutes performance. So we were, as I was saying, exploring different settings. What you could see here was first the duo of Simon Rose and Ingo Reulicke, then the trio between the three of us, then having Ingo control a virtual agent trained on the baritone playing of Simon Rose. Then you see the performance of Simon together with the virtual agent trained on my own guitar playing, and then a duo between these two virtual agents. With Federico Visi on the right hand and me on the left hand, but it's actually these two virtual agents that you can hear playing. And so in the research, we were very interested in finding different modes of co-agency between the artificial and human agents and developing modalities of exchange and performance that would really bring also the different sort of, let's say, musical possibilities that you see with arising within this space to shine. And I think really finding space for all these different agents to shine through was a major part of the discussion and the rehearsal process. And on the other hand, of course, finding the exchange between virtual agents and human performers, which have a very different, let's say, dimension of embodiment, which is also manifest in the different setup of the two virtual agents. And concluding, I would say that the embodiment nature of human interaction gets foregrounded by the different exchanges between the human and the artificial agents, as well as the interaction between music and dance, which of course is a major point in this research project. Thank you very much.
Sorry, I didn't understand. It's my turn, right? Yeah. Cool.
Andrea?
Yeah. Yes.
Can you hear us?
Yeah. No, I couldn't hear very well, but I think it's me, right?
Yeah.
Can I go? Okay, cool. Oh, cool. Excellent. Okay, now I can hear. Okay, so I'm talking on the behalf of this team of persons from Casa Paganini Infamous, which is a research center in Italy. The project that I want to show here is called Danzarte, and it is a protocol for the treatment of motor, cognitive, and social frailty in the elderly population that in Italy is very large. Basically, it consists in a series of therapeutic movement sequences that elderly people does, imitating an avatar which is projected on a wall or on a screen. It is also a group experience because you have 4 or 5 elderly persons doing this game, helping each other with the presence of one assistant. And it has this kind of social, local dimension where the movement which are to be imitated were extracted from historical paintings which are visible in local museums. So these people do these sessions. There are 4 sessions in a month, but they also go outside their community centers to go to the museum and see the historical paintings from which the movement were kind of extracted in a way. So there is a trajectory from the individual movement to the social experience of the region. This is an example, a photo from this kind of experience. So you have 2 active participants. In this case, they are framed by a Kinect, which is talking with a computer, with a system that I explain later. These are the avatars. I hope they are visible enough. So they are modeled from some mannequins that were used by a pre-Baroque painter in Italy to sketch the works. And these are waiting or non-active participants that are imitating the others and helping them do this game. Okay, so of course, in fact, the system is a kind of distributed intelligence system where you have one active user, which is, or 2, like in the photo, who is providing input to a Kinect, to a system where the main brain is a conjunction of IceWeb, which is the software developed by Casa Paganini, and a super module made by Python, which is like the big brain of the of the game. This guy basically observes the users and decide how the session has to go. So decide when to show with a video player and a projector which movement has to be performed, if new movement has to be introduced, or if users have to repeat the same sequence, etc. So it determines the scenario of the game. And also IceWeb and Python, they communicate with MaxMSP, where there is a patch for the sonification of the quality of movement that we are looking for, which is fluidity. So anytime there is a fluid movement in the avatar or in the persons, MaxMSP provides a kind of positive feedback, which is a sonification of the movement. So, and also, of course, there is the presence of the waiting users who are looking to the active and looking to the image and listen to the sound, and together they form so this kind of strange autonomic ecology of minds, human and non-human. And what's interesting is that the system stays active for almost 1 hour. There is just one assistant that sometimes stops and launches, makes some pause to explain. But so you have 4 or 5 frail people in need to do exercise, etc., that they interact with this informatics system, and between them, and they go alone 1 hour of exercise. So briefly, the sound has, in this very complex system, has a very simple task, which is to suggest fluidity in the quality of the movements. Of course, create reassurance and not being distraction or intrusive. I won't explain how it's done because we don't have time. But I use granulators, and they are fed by data from IceWeb. Maybe if there are questions, I have slides on this. I just want to conclude that the system was tested with more than 200 persons now. It's very popular in the world of elderly care now, because it's very effective. You need a computer, the Kinect, which is a little bit complex, and a couple of loudspeakers, a projector, and then for 1 month you assure a good level of activity. We made one clinical trial with 10 persons and 10 controls, and there is significant improvement in resilience scale and psychological general well-being index, which is very important because with a very little effort, you can really change the life of these people. There is no significant change in more physical parameters, mostly because the first parameter is very large. It comprises lots of dimensions, like also nutritional stuff, etc. The second is, I mean, there is one thing that improves, and it is the balance, because the movements are made also to shift the weight between legs. But there is no strength exercises or sit to stand. So basically, hand grip and this one, the short physical battery, are not really improving. But this is because of the kind of the exercise. And I can stop here, and maybe if we have questions, we can talk about the technical. Way. Thank you.
Next up, we have an in-person presentation by Dan Overholt and Robin Otterbein, out of which I guess, hi Robin. And the theme is Improv AI's, a new bridging project for embodied perspectives on musical AI.
So I'm going to talk about our research project at Aalborg University, Copenhagen, called Improvise, using deep learning to improvise real-time motion recognition and effective experiences for human-machine interaction, which I'm doing together with Dan and a couple of others. And first, some overview. The research goals of this project is to develop intuitive audiovisual displays that accurately reflect physical activity, and first and foremost try to analyze and make use of the felt experience of the human movement. And we use ML techniques to try to utilize these sensing signals and provide high-level information about the user's emotional and affective states while moving. And this was a collaboration with BioX, a company based in Aalborg, Denmark. And they produce these sensor bands that you can see down there. These are multimodal wearable sensor bands, and they utilize an array of forest sensing resistors and also employs an IMU. And they work in the field of rehabilitation, exoskeletons, robotics, to use these sensor bands to control in these fields. So, and first I want to just show what we also showed at MoCo. There's a long paper published, and that was a demonstration that we did. Yeah, I hope you get the idea. We were working together with a contemporary dancer who was using 4 of these sensor bands on arms and legs, and we were using her expertise in communicating these action perception loops in an iterative process, and try to make sense of very similar to Sarah's CODA presentation yesterday, that relates a lot to this kind of artistic process where we try to find these insights and feed them back into the development with like an industry that is usually not working together with movement experts or like dancers or arts in general. And that was a very interesting experience, and we used low-level motion descriptors as well as high-level motion descriptors, especially Laban effort, wait time, space, and flow. And here's the interaction scheme that you just saw in the demo, and it is basically everything developed in MaxMSP and some in Python. And there's a movement analysis system, and the most important part of it is the feature calibration. So we were able to track and calibrate the Laban features as well as the FSR for sensing resistors, movement features that we could extract from all the sensor data and adapt it to the individual body. And that is mapped via a mapping interface, so we have like real-time on-the-fly mappings to an audiovisual system that is a granular synthesis and a physical sphere and particle system that we can control. And our improvise starts exactly at this point. We tried some different things, for example, using it with Rave and DDSP and control the latent space. And this is how the mapping interface looks like, and we can leverage the movement data to actually control the latent space, which we've also seen like in a couple different works yesterday and today. And our general workflow is we have workshops with dancers, music therapists, physiotherapists, creative technologists, engineers. So we really try to reach out to different, try to gain different insights and perspectives, and work together in this collaborative research and try different things. Next steps is going to be the how do we incorporate AI into the movement analysis part and as well as the visual part, and how can we take advantage of it? Thank you.
Thank you. Next, we have Face Player, a modular embodiment system for ML-enabled performance technologies by Jason Palamara, who will be joining us on Zoom.
Can you hear me?
You're very quiet, but yes.
Yeah. Okay. So yeah, you can just share your screen and yeah.
I'm doing that now. Okay. So that should work. Okay. Hello, everyone. I'm Dr. Jason Palamara from IUPUI in Indiana. So the system I'm presenting is called Face Player. So this started as I have a project named Avatar, which I work with Professor Scott Deal. And we've been working on various ways to make it more social. So the Hanson Robotics, who developed the Sophia robot, they wrote an article called "Why Build Robots with Faces" that goes into this in great deal, talking about why it's important to have the robots look like us and be social and sort of exist in that space. I've also spoken with Gil Weinberg, who, along with Richard Savory and a number of other researchers, has been working on this robot named Shimon that plays the marimba. He also says that that when people are researching in his lab, he likes to adhere to these 3 rules: listen like a human, play like a robot, and be social. So basically, if the social aspect of the system is missing, then it's not doing its part. So you can see that in the Shimon video down on the left, that it actually blinks and moves its mouth when it sings or speaks. So this is a performance of Scott Deal. I don't know if you all can hear that. But when Scott plays the vibraphone, the avatar system's listening via these microphones that are above his vibraphone, and it plays back, or it actually plays in real time and interacts with him. It works really well. Scott is very happy with it, but it is not social in any way. In any meaningful way. So also when I was speaking with Professor Weinberg, he had a number of options, because, I said, well, I'm not a roboticist really. What would you recommend? And he said, well, you should get into animation. And actually at that point I wasn't really into video or animation as well. So I thought, well, let's start with 2D videos. And I came up with this plan to sort of scale up eventually to working with interactive animation. And a sort of side step was to work with what I would call a robotic performer that's already pre-manufactured. This is our performance with Avatar controlling a Discovir. That sort of work's been done by going back to George Lewis and many others. So before I get to the video aspects, I wanted to talk about this collaboration I did with a number of dancers involving this system that we call the telepod. The telepod basically is just a screen upon which we can project, and you can have performers standing inside of it. My whole idea behind working on this system was eventually we would be able to use this with AI as well. So the first iteration I did with this was with a dancer named Catherine Butler. And I attempted to put these things together. I had her make a number of videos. This is one of them here, of just her dancing and improvising. And then I would have Avatar play these videos, sort of like, make its own choices as to what it would play back. That didn't work out as well as I had hoped for a number of reasons. For one, the dancing, to most of the people who saw this, the dancing was pretty abstract, and it wasn't very tied to the sound. So even though there are dangers with things like Mickey Mousing and tying it too closely to the sound, what I was actually after is tying the sound to the visuals very closely, so that you could actually get a sense that the machine that you're looking at is actually playing. The other thing is, when we had the system cut the video up, it actually at least one person who had a dance background said, "You're really doing violence to the dance at this point," even though Catherine was hip to what we were doing, and she was on board with it. It takes her very smooth, fluid movements and turns it into something choppy. So the next move I made was to come up with a linear video. This is just a test where I made a linear video of my own face. So I put that into the system, and I think I have to play this. So this actually gave a much better like one-to-one correlation of when the video was playing. You start to get a sense that over here is a high note and down here is the low note, just as you would if you were playing piano. So here's the system all put together with a disclavier. And you can have a little bit of fun with it, with sort of dramatic poses. And this was sort of an early system where it was just playing sort of still images. But so we've had some further success with this ensemble. But the problem with this was that the videos actually sort of turned away from the ensemble. It's very difficult to sort of get the angle right. And the other problem is that the disclavier is very difficult to transport. So it means, if we were performing in one room where the disclavier was, great. If not, then we sort of can't use it. So my next adaptation was to use my students, to have them make a linear video and perform the piece, perform a number of pieces with them actually looking out. So the intent is that the telepod would actually be inside, in the middle of the ensemble, so it would look like a real ensemble member. And that's why we also had this, we came up with this idea of what we called loiter mode, which was when the system is not playing, it just sort of sits and loiters. So it looks a lot like a human member of the ensemble. We also embedded speakers in the telepod, so that there's actual direct sound coming right out of it, and also going into the audio system. I do have a short clip of that. Just this is sort of the test. So the final test of this will actually be done in a couple weeks at a large event we do called the AI Music Experiments event in Indianapolis, and we'll actually do a live Turing test with some of the other AI stuff going on here. And thank you for your time. That's FacePlayer.
Thank you. The penultimate talk today is called Using Biosensors to Amplify Music Embodiment, and it will be by Jason Snell, who is also joining us online.
Hello. All right, let's share screen, share sound. Are you able to see that? Yes, I see the screen. All right, I'm Jason Snell. I'm an artist and creative technologist with NYU, the ITP program. A little bit about my background. I started producing music in the mid-90s, techno, experimental, hardcore, industrial, some very unpopular niche music. I had a lot of fans in like really random small places around the world. I transitioned over to film scores for a few years, 2006, 2009. And I got to a point where I wanted to explore what would be different ways to compose music rather than just using a drum machine or Ableton or synthesizers. And I started first playing around with generative music. This was in 2009 when iOS apps were first, the development kit was released to the public. And then in a very backwards way, I stumbled into an AI because what I was doing was I was documenting and recording the users' taps. So as they were using my app, I was taking that information, and instead of using randomized information, I was using their previous choices of what instruments they were choosing, what notes they liked, and started feeding them back into it. And I wasn't doing a direct translation. I was running it through a generative algorithm. So there was some randomization where sometimes the less common ones would win out. And what ended up is this really kind of organic, let's move to the next slide. What ended up is this really organic, play that. What surprised me was using the system, I started to do performances with it and kind of these long jam sessions. So essentially I had this robot bandmate, and when doing, we weren't able to compose at the same time. Essentially, I let the AI compose, and then I turn the knobs and choose the sounds. And if we were both trying to compose at the same time, I think there would have been a real struggle in terms of communicating what's my intention, what's the AI's intention. And so by having distinct tasks, we ended up having this really emergent phenomenon, almost like an organic entity emerging. And I made this, well, I didn't make it, but this AI made this like really nostalgic, beautiful video. It was using processing, and it was composing the music. And there was a label that I'd been trying to get on, this avant-garde label in Germany for like 2 decades. I still haven't gotten onto that label, but the AI did. And so I felt pretty bummed out that it totally had beat me. And the way it did it is made this like very human, beautiful, I can brag about it because I didn't make it, it made it really beautiful piece of music. I was a little butthurt by it getting onto this label, and I didn't, so I switched over to working with people and not working with AI for a period of time, and started working with dancers. So I'd met a dancer in Berlin. She had used motion sensors in the past to control the lights, and she said her real wish was, could she control the music? Could she compose music with her movement? And I was used to doing that in the AI world, decomposing music and reconstructing it in real time. And so I worked with her and worked with several other dancers. This is one in LA, using the Maya wristbands, as you mentioned, and mapping sounds and movements with the dancer. This one, he chose the sounds he liked, and he chose mapping that he liked. And what was cool is we started to see this real powerful where the dancers just feel super powerful. Like they move, and question goes over there. It's just such then I moved from motion sensors to biosensors. So I started making music from thought. I was using EEG and then heart data as well, and really started to get into how the body composes. And this is one of the places where I see AI doesn't have, I haven't seen real access with it yet, is that what if the AI was given EEG data? Because the AIs I've experienced, they examine what the result of the music is, you know, the end result of the musician's work. But what if the AI was given information of what the musician is going through psychologically and physiologically while they're making music and getting excited about it, and recreating the space in which creativity happens? This is a short snippet. In my own EEG work, I would map my brainwaves onto my body, so they would map around me through a projection. It was this mixing of bio art and music and neuroscience. I can tell that that's me. There's my hand. Moving on. So the idea of play. So humans are unique. Like, we really can't take care of ourselves for many, many years. Whereas other species, when they're born, they get self-sufficient pretty quick. The point of that is that it allows our brains to have these long periods of time so we continue to have plasticity well into our lives, so we can continue to learn new things and play. And the idea is that we make lots of mistakes, and we have this space where you know, when we're 1, 2, 3 years old, we don't have to figure out how to like get food and like protect ourselves, because we're given this long period of time of play. And so the idea is, what if AIs were given that their original task didn't have to be so functional and so productive, and giving them access to our internal biodata and essentially replicating this growing up experience, and what sort of creative solutions could come out of that. All right, that's it. Thank you.
Thank you. Last talk for today is going to be about continuous gestural interactions in live coding by Georgios.
Is this a mirror? Yeah, okay. It's mirror. Scalar as audio output. Yeah. Okay.
Yeah. Hello. I speak here. Here. Well, hello. My name is Georgios Diapoulis. I am PhD student at Chalmers University of Technology and University of Gothenburg in Gothenburg, Sweden. I'll be presenting you about continuous gestural interactions in live coding. So the idea of continuous gestural interactions is that, yeah, it's not exactly a control. You don't adjust the filter knob that you control the cutoff frequency. It's just a system that is a rule-based system, but it can have quite unpredictable behavior because of I advanced the levels of abstractions there. So what is live coding? So live coding is we just apply on-the-fly modifications on a running program. I mean, literally, it's like hot swapping. So we have a running system. Here we see a hardware server. And there the programmer is just putting a new hard drive. So the idea is that the system is always on, and we just hot plug a new component. Metaphorically, is the dramatization of a computer program. There is the notion of drama, so we have acting, and we act on algorithms. This from Collins. Now, the term appeared in early 2000s, but there are historical precursors like Roncoivilla in 1805 in time. And the hub, the ensemble, the group, the hub, and similar fields are like liveness in programming environments, education of programming. Live coding is considered a very good approach to teach programming. And it also expands to other audiovisual and performing arts like dance and visuals, etc. So what is canonical live coding? Canonical live coding is how more or less everybody seems to understand live coding. It's just we write a computer program on the fly, and it began in early 2000s. We write algorithms and we subsequently manipulate the code. Typically, we project our screen for transparency about sound production. Now, eventually, here there are no sound producing gestures, but eventually the coder here is just nodding to the beat. So there are sorts of secondary aspects of musical gestures when you live code. Now, how we live code, it's just a trial and error. We just try things. Typing is a serial skilled action similar to how we perform with musical instruments. But there is an indirect involvement because of notation. And here I refer to Lehman that there is no reference. Lehman, the Embodied Mind book. It's a conscious activity. I mean, you put some effort there. Now, what is hybrid live coding? Hybrid live coding is a live coding paradigm where some other interfaces, they are in place. So here we see Al Jazari by Dave Griffiths. It's a video game with agents and they have some autonomous behavior, etc. There are more systems, like here is Code Clavier by Noriega and Weinberg, where there we see the pianist actually making sound producing gestures. And this is like an example by Frederick Olofsson, where he live codes on the signal level, like the very DSP thing. And and there is also a conference workshop thing, live code, hybrid live coding. Now I'm running out of time, so I had a project 12 in 2014. There was a publication about tangibility and low-level live coding. So here, what I do is that I provide the input in bits. I just input a 3-bit word, and then I advance the levels of abstraction. So from bits, I move to symbols, and from symbols to tokens. So in principle, this generates a formal language on a mathematical level. It's like a very basic language. So then I redesigned this, and I have a demo. If you would like, you can check it. So I adjust this in order to examine whether pre-reflective processes may be activated during live coding. By pre-reflective process, I mean fast process that they are between 2000, below 2000 milliseconds, so like without conscious effort there. So I just redesigned the system, and there a feedback loop is taking care of the input, and the user is just varying the variable clock, and there I examine notions of liveness. So now, because I know the system, I can see what would be the next token, but in the demo I have visualized this also on the GUI, where here is not shown. But yeah, that's from me. Thank you.
Thank you so much. If I may request the live speakers to join on the panel, and for the Zoom speakers to please switch on your videos, please.
Do I keep this? I keep this? you some.
Thank you to all 6 speakers for really interesting sessions through this really interesting papers, presentations, and through mapping and control, we saw a whole range of activity from composition with AI tools to motor, cognitive, emotional frailty rehabilitation and therapeutic games to development of a new system. Is this feedbacky? A little bit.
Is it giving any feedback?
Yeah, a little bit. So I have several questions, and I thought that it might be interesting to start with one of the ideas that was brought up that stuck with me a little bit, which was doing violence to the dance. And I was wondering if we could start there and start talking about the idea of using machine agents that would chop things up and reconstitute those things, and what does that mean for for the evolution of the art form in general, and for the specifics of reconstitution in particular. Sorry. I don't know if any of you wants to take this question, or...
Well, I brought it up. I guess I could do it. No. Yeah, the great question. I would say, I would feel really weird about doing that or having my system do that if the artist herself wasn't involved in it. But because that seems a little bit too appropriative. But still. I think there's also something that should be discussed is, Catherine, who worked with me on that project, knew that I was working on this long-term project, but she didn't necessarily know that I would be using it still in 2022. So I mean, I think that I've started to think about that more when I'm working with artists who are going to bequeath to me their data in some way that I'm like, this kind of doesn't go away, I mean, you may see me in 10 years and I'm still using your video, I mean, it becomes like this weird avatar artifact that lives on, after the person is not necessarily, gone in the, death sense, but, at least, I mean, I haven't checked in with that artist in a very long time. So, I mean, it is something that's a little bit weird, definitely, and I wish, that using the videos in the first place was really just a stepping stone to getting to more things. I mean, I'd much rather generate an animated video that wasn't really tied to somebody's face, but I guess we'll get there when we get there. I'll get there when I get there.
I'd definitely echo that. The video I showed of the dancer, since those 5-6 years ago, since then the dancer got in a really terrible motorcycle accident and no longer has one of his legs. So it's this very transformative accident that happened to him, and this footage is this glimpse into the peak of his career, and there's a real pain there in that I don't want to erase it, because it was such a beautiful moment of him using the system, and I don't know how to reconcile that with the current state of his body, which is very damaged.
Yeah. I thought we could talk also a little bit about this in the practice of co-agency. I think someone in this session mentioned, or in the keynote mentioned, something about using smaller data sets for specific artwork, where also kind of specific types of data are involved even though they might be yours, as in your case, Nicola and Federico. Would you like to elaborate on how to negotiate between kind of your own data and the reproduction of kind of your own work in the context of this idea of chopping up and reconstituting?
Well, something that I came to realize by having a lot of exchange with people that particularly in Vienna and in Berlin, that I met working within literature and AI and using AI to write text, which of course we all know many examples of, is that I've found that in music I can see a lot of artists that I can see around me that are somehow related to experimental music, improvised music, and so forth. And I mean, I myself, I sort of started out doing this kind of practice because I got the chance to work with George Lewis over 2 years at Columbia University. And I can see a strong interest in sort of like working with very specific data sets and very specific sort of like musical languages, in a sense, that are manifest in this, which in a sense, if I was working with data sets that in a sense wouldn't be so personalized, that wouldn't be possible. And I became very interested in seeing like where does the musical language of a musician go when the musician actually isn't there anymore, but the musical language sort of takes on its own route. And what I found very interesting to see is that in literature, that obviously didn't, at least to those people that I saw, and I think definitely if we think about GPT-3 and other examples, we can see there is a strong pull in another direction where we are more interested for different reasons to work with very big data sets, where, for example, also the transparency of the data set becomes a whole other issue. And of course, you wouldn't at all consider a relationship between let's say, a data set and some artistic persona. And I just thought that this is sort of interesting to see that in some sense, at least to my reading, seeing this practice within music has a lot to do with the history of jazz music and the inflection that the jazz history still has in these experimental music practices of today.
Thank you for that. That's really interesting what you say about jazz music and kind of the impact of that on improvisation in general. I have a question about more the concrete, I guess, but it is to the IMU AV display paper, because there was this slide about space, flow, time, and weight efforts. The Laban effort categories, but I was wondering how they're related to, since we're in the mapping and control domain, how they're related to the kind of raw or actual data that you obtain from the sensors.
So yeah, it was really interesting to work with Laban effort. It was one of the first versions to try, or for the first attempts to actually try to extract high-level data instead of working with very low-level, very noisy data that we get from the sensor bands. And we also retrieve it in a very high sensor, in a high data rate, like 700 hertz. So we were investigating how can we get closer from the raw data to the actual movement intention, to the kind of characteristics of the movement, to the expressive features. How can we somehow, somehow make an assumption about how someone is moving and how is someone being affected while moving? And we've been leveraging Laban effort for that reason, and especially when using the acceleration data, linear acceleration data that we retrieve from the IMU. And then we had the problems that all the features, weight, time, space, and flow were correlating, and they were not really that useful on the sensor band right away. So it was an iterative process on developing a calibration routine, and that was very, very much the focus point of these iterations, which we in the first place didn't really see like coming, but it developed to be more and more an issue to, or the importance to not have assumptions on the human body, but to see everybody as an individual person with abilities, a different movement range, and different movement qualities and interpretations of movement. So, and that's how we like started using 3 different factors of like range and sensitivity and responsiveness, incorporate them in the process to use linear acceleration data to get closer to what the Laban features actually express, and that was going better and better the more we tried these calibration routines.
So that mapping is not learned; it is.
It was deterministic.
You might mention the latent space
Yeah.
for experimenting with it now.
It's an embedding, or, yeah.
Like for now, it has been deterministic.
Yeah.
And that is especially what we are like trying to do now. So how can we, from this like deterministic approach, then go over to, without losing like the calibration routines and incorporating all these things, but actually into an AI model that can bring us even closer to a felt experience and an intention, extracting an intention from a movement. Hope that makes sense.
Yeah, it was really cool. Going from here to gesture, the addition of continuous gestural interaction in live coding, because as I see it, I mean, it's a big jump, but it's not really though, because there are a lot of elements of movement-related sonification and embodied music or sound noise that don't find space in live coding in general. And since your historical overview of live coding was really interesting, I was wondering if you have thoughts about how or why. What is the gap that disallows us from calling kind of movement-based interactions? What is it that would be needed? What is between those and live coding?
Yeah, well, thank you. I mean, I don't have the answer apparently, but I think, for example, when I was developing this, I was thinking like, if anyone here knows digital design, digital logic, I mean, you can use a 3D projection of the space. And so I was thinking just to map the 3 bits on a 3-dimensional space, etc., based on how they do that in digital logic. So you have to like base your approach on some kind of arbitrary mapping and then explore from there, I would say. I mean, as I understand in the Laban movements, and as far as I know, the Laban is about qualitative features, right? So I think it's an excellent point to just start from qualities and then try to map them from the qualities to the, let's say, hard indicators, the hard features. Yeah, I haven't put much effort into what qualities should be, mapped into live coding, bodily qualities. But I mean, and here in Rhythmo, you have done a lot of work here on movement. I mean, there is a big field in music psychology that people do movement studies, and I used to do that in my master's also. So many things are well known, like, we move more on whatever, the swaying axis, if we would like to be expressive, and this type of stuff, they're pretty well known, so maybe we can start from there and just, based on what we want to do, just make some common sense mappings, I would say. Yeah.
Yeah, I guess something about the kind of modern move towards no-code systems comes to mind for me as a kind of, are we moving there in our areas? Dan disagrees with me. do you want to say more? No, it's just, an idea about kind of the demonstration of what is unseen in computing as being kind of the broken wall that was the spectacle for a lot of live coding, and we're kind of remaking and unbreaking that wall in a different way by doing these kinds of resynthesizing systems, maybe, perhaps. I would like to also ask Andrea about these kind of very promising results in movement therapies. Perhaps I wanted to know a little bit more about the sonification element within the kind of agent representation and interaction.
Yes. I'm sorry really for that we haven't so much time. So I want just to say something. The first is that we too we use a very simple mapping concept because we have elderly persons. We can't expect an ideal body, but yeah, on the contrary, very different styles of performances. Also because the elderly population is not one type. At least there are two groups of age. So basically, we use a super simple way of communicating, where basically we look if they move the right limb. This is the first, because it's a very cognitive element test that, and then we just take quantity of movement and smoothness. And we work only on these very, very general parameters, which is at the same time probably a limitation, but also a great strength, because it can work with very different persons. Do you want that I tell you very, very quickly how we do the sonification, maybe? Basically, can I share quickly the screen? It will be very, very short. Well, basically, we use granulators. So basically, we access a prefabricated sound file, which is made from very strict rules of control of spectral morphology. And basically, we control the volume and just the volume and one low-pass filter using quantity of motion and smoothness of the user and of the avatar. Then there are lots of features that I won't talk again, which are related to the low intrusiveness sound design paradigm that we are using. We are trying to be less invasive as possible, so the way these sounds are made is also related to how to transfer information in the least intrusive way. It's off center with this conference, so I won't talk about this. Another thing that I wanted to say about property of data, I forgot to say that the avatar movement was created by two choreographers, which are specialized in movement for elderly persons. So they designed the movement of the avatars, having in mind the possibility of movements of the future participants. And then we acted on those motion capture. We transformed a little bit. We made a little bit slower, a little bit more fluid than the real motion capture, which is also interesting. We didn't use the pure data as it was performed, but we kind of idealized a little bit in order to offer to the viewer a kind of persona of movement, a kind of ideal smooth movement, which is extremely difficult to perform in real life.
We have only a few minutes left for a couple of questions, if any. Yes, please.
The question goes to Jason Snell. I was wondering, when you started working with the dancer, how did you do it? With what kind of methodologies or intentions, and how did this work inform or inquiry the creation of the interactive system? And the second question is, what kinds of AI models or algorithms have you been exploring in with a dancer?
With mapping, one of the things that was really important to me is that the sounds felt really good to the dancer. So it was more of an intuitive or a feeling rather than looking at the technical aspects of their movement. And with each dancer, it'd be a different sound kit. So for the example, the first dancer in Berlin wanted these very percussive, sharp sounds. And then the one in Los Angeles, which I showed you footage, wanted these very human sounds, just took a field recorder and he would like hit his chest, make these guttural sounds with his throat, and then have those transform into machine sounds, in which we took different samples and twisted them together. And in the course of that performance, we go from human sounds to machine sounds. And I found that when the dancer really likes those sounds and is excited about it, it creates a more powerful biofeedback loop. And with the mappings, I created a software was really fast to map. Okay, you gesture, this way or this way. How does this sound feel? How does this other sound feel? And creating these kits to go along with certain gestures. So it wasn't the exact same sound each time, but it'd be a similar sound. So there was some randomness, to emulate life. And that mapping process ended up being faster and faster, and that the person, there was this cognitive pleasure between that movement and that sound. With the AI work came before the motion sensors. And so it's about looking at how, originally I was like, how do I incorporate, the AI system into the motion? But I was getting so much information from the body that it didn't make sense for the AI to contend with it in real time. So my AI work was the musical work before the motion sensor work.
Awesome, thank you so much.
Great. Are there any, we can probably take a question.
I can have one question.
Yes.
Well, it's partly connected to what I asked to Sarah yesterday about. I asked her how they, when they play together as multiple people, like in the Coda project, like how they keep this balance of ambiguity and control and that sweet spot. And from her answer, I realized that it's kind of very intuitive and almost very, for humans, it's quite easy to feel some kind of groove going on between, when you're playing as multiple humans. But when you replace the human with artificial agents, so then it becomes tricky, right? Because if we were dealing with some more pitch-based music, then we could, for instance, if it's like a blues jam, then we know that, okay, now the agent is playing outside, or now is playing outside of time and so on. But when it's more like electroacoustic and experimental sound-based aesthetics, then it becomes quite hard to evaluate even for the player itself. So what really inspired me to ask this was mainly the Nicola's and Federico's work in this context, but it goes to everyone basically in this room. Like, how do you really feel, how do you really sense the agency or how much you like what's going on, or how much you dislike what's going on? What are your conceptual or practical measures? It's quite an open question, but
So I would say that maybe working in a group that is composed of human and virtual agents is a different situation than, for example, being in this situation as like the only human performer on the bill, so to speak. So I've done a lot of performances where I use a similar system to the one that I was using in this project that I just showed you, where I have a model live train on my guitar playing and I'm on stage, and basically while I'm playing, this virtual agent starts learning and then it starts becoming more and more independent. And every time I do this piece on stage, I have a very similar sort of experience to when I play in a duo with another human performer, which oftentimes is you start playing and there's this negotiation process where you start to figure things out. And at some point you stop thinking and things are clear. You found your groove, so to speak. And that experience I definitely have every time in a very similar way when I play duo with these virtual agents. Now, of course, I know saying there would be some form of similarity is maybe a strong anthropomorphism on my side to say this, but definitely from, let's say, the musician's perspective and psychology in this moment, I feel like there is a very similar process where I feel like we start negotiating, and after some time, depending on the day and the gig, you really feel like, okay, we have found our groove, and then really definitely also my interaction patterns change as well as the ones of the virtual agent. I think in a group like so that's one side, and then in a group like the project I just showed you, I think that's sort of, it's another issue, because then actually you have the problem of how do we not overcrowd the space with like information, because basically, and I mean that in some sense is very similar also to human groups, is if there is just too much going on, well, there's just no like clear focus in the music. And that was definitely in this group a point where I felt like that was the main meat of the rehearsal, was like, how do we actually adopt a habit where we as the human performers are able also to deal with the space that is necessary and to also give that space. And on the other hand, also deal with how the virtual agents behave. Like, for example, my virtual agent, when it would interact with the dancer, what it would be reacting to is the sound of the dancer moving, not the movement, but the sound that he makes in space while moving. Well, that's something to figure out, right? And then at some point that comes out, and then you find your ways of how to bridge. And I think in some sense, then the sort of the experience of playing in some sense has a similar sort of vibe to this question, like how do we deal with space, and do we find a good balance about space that is sort of like gratifying? But that, of course, again, that's just like the sort of the musician first person perspective in this, but I think that's very relevant, because that's sort of the basis that I have to work out a musical interaction regardless, because well, that is sort of the perspective I can maximally have, which maybe also goes back to this other minds problem that was mentioned earlier.
Important aspect of a more symbiotic kind of interaction between human and artificial agents.
That is definitely something I would subscribe to, definitely. I mean, I make the experience quite often that when I work with online learning virtual agents, I find them way more empathetic in how they behave musically than if I work with a completely pre-trained process, which also is partly due to the fact, right, that whatever way of recording that you use and all of this makes a huge difference to what the virtual agent might do. But of course, if there is some let's say relationship to the moment that the performance happens in, that's one aspect. And then of course the other, yeah, I think really timbre is such an important element of this. And the other thing is really also musical content, which I think you can play with in a very different way than what you could do if the virtual agent would not be training online. And I think you find a whole other way of relating. I mean, yeah, I think it's, for me, oftentimes it's a version that I prefer. Well, of course, on the other hand, I mean, there's other circumstances where it might be really interesting to not have any form of online learning, and that can still be great. And I think one element that sort of, to me, often as a guitar player, I mean, that's a very relevant aspect, is my signal in this learning process is always like maximally distinct. While if you have microphones in a space and you project sound back into the space, you get totally other problems that somehow you need to find a way of dealing with. So I think the perspective of like recording and then playing and having possible sort of like learning feedbacks or whatever in this, that's another element in there that I think has to be considered.
The curation of AI tastes is finally by human agents, and that's how it will be in the foreseeable future. That's it for the session. Thank you so much to all the speakers, and thank you, Chai, for letting me do this. And we have some more announcements.
Yeah, well, yeah. Thank you for all the presenters who are here. Thank you. A few practical information regarding the rest of the day. So let me just share my screen. Projector, HDMI. Oopsie. Okay. Yeah. So, well, we're done with our sessions that are here. So from 5 until 7 we will have some kind of free time, if you would call that. And then at 7 we will meet at the science library. And if you click on this link, you will see the map, which is like 10, more or less 10 minutes walking distance to here. It's closer to the music department that you were yesterday. And one, I think, important thing to remind is that if you want to, because we didn't really plan anything for the dinner today, unfortunately. So there are a few options, and if you want to stay in the campus, there is one kind of common dining hall, which is called Frederica Spicery, which is very close to the science library. And if you zoom out this map, so this is where the science library is at, and this is Frederica. And there's this large square here, and it's really like 30 seconds walking distance. And that's open until 6. So you have 1 more hour to catch some food there. Unless you want to go somewhere outside of campus, which you can also, like, you have 2 hours to do that. And when it comes to concert, we will first have this thematic performance. Half of it you've seen downstairs in the lab. Half of our master students are located there, and the other half are located in the science library. And after a short break, we will have this keynote performance of Koray Tahiroğlu. It's going to be some kind of a mixture between an actual concert and a talk. And the last event of the day, and also the entire workshop, will be a panel discussion with our invitees, keynote invitees, and some additional panelists which will be moderated by Stefano Fasciani. Yeah, I was thinking to make the thank yous right now, but I decided on doing it in the very end, because it's going to be a little bit weird to thank everyone and then thank for the people who will take place later in the day. So like I will do it later, but still thank you for being here, and yeah, we will. I hope to see you, most of you, in the concert. And yeah, any questions so far about anything, any practicalities? No? Good. Okay, then you're free to go for 2 hours. Thank you.